Hello everyone, and welcome on behalf of World Fish Migration Foundation, the United States Forest Service, and the Nature Conservancy to this webinar about removing road dams in Europe. Thank you very much for taking the time to meet with us today. We are thrilled to see the positive response to this event, and we have registered more than 1,300 people from 67 different countries, and that is simply amazing. I see that the numbers in the event are growing, so we expect and we believe that this is going to be an amazing event. We will listen during this webinar to more than a dozen of experts on river restoration, river barriers, and freshwater ecosystems, and I would like to thank them too for being here and share their stories with us. Today's webinar will address the challenges and opportunities to enhance the biodiversity of our rivers by improving road and stream crossing, because river fragmentation from constructed barriers poses one of the greatest threats to freshwater biodiversity and also to river ecosystem functions. This event is going to build on experiences from projects and best practices across the United States and Europe to bring the much needed attention to this issue, which is highly common but often overlooked. At Wetlands International, we believe that healthy rivers are essential solutions for the interlinked crisis on climate change and biodiversity loss. European rivers, as most of you know, are the most or one of the most endangered ecosystems in the world. And there is an estimation of 1.2 million barriers just in Europe obstructing rivers. And more than 200,000 are culverts and road crossings, blocking not only fish migration, but also altering a lot of river processes. Our rivers, imagine, are so full of barriers that for nearly 40% of affected waters, we don't even know what's the purpose of the barrier. And as a result, migratory freshwater fish populations have collapsed by 93% since 1970, and iconic species such as the sturgeons or the eels are critically endangered. In case after case, we see how ecologists say that nothing compares to removing barriers in terms of the benefits to a river. So action for European rivers, and in particular barriers, has never been so urgent. And that is why also Wetlands International Europe is a partner in Dam Removal Europe. It's a coalition. So we open together the gates for free-flowing rivers by restoring at least 25,000 kilometers of rivers through removal of barriers and through the restoration of floodplains, as it is set in the European Union Biodiversity Strategy for 2030. Now I'm going to provide you with a couple of tips and a bit of an explanation on how you can participate in this event. First of all, you will be all muted. However, there is a chat box. If you are familiar with Zoom, there is a chat box that you can find in the lower side of the screen, where you will be able to drop your questions. If you have any question or you don't know how to use it, please drop your questions there and we will try to help you. If there is a particular question that you want to address to a specific speaker, please write down his or her name so we will better manage those questions. For some presentations, there will be space for questions after the presentations. For some, there won't be time. But at the end of the event, there will be a session for discussions, and you will be able to ask your questions to these speakers. All the presentations will be uploaded in Dam Removal's Europe YouTube channel. My colleague Nicole will copy that link in the chat box. Introductions. So with me today from World Fish Migration Foundation are Ruben Van Trek. He's our questions and answers and chat manager. Nicole Friedman, who is our event manager, and Herman Vanningen, who is the director of World Fish Migration Foundation and the host of Dam Removal Europe, and he will support me in my moderator role. Dan Senderelli and Mark Weinhold from the US Forest Service will also help us manage the questions. Of course, I would not like to kick off this event without thanking to the organizations who have made this possible. The World Fish Migration Foundation, the US Forest Service, the Nature Conservancy, Wetlands International Europe, Oregon RFID, Biomark, the Dutch Postcode Lottery, and H2O Acoustics. So now let's get started. Our first presentation comes from the United States, where Nat Gillespie from the US Forest Service will explain us what is the problem with culverts and road crossings. Nat works with the US Forest Service as the Assistant National Fish Program Leader in the Washington, D.C. headquarters. He has worked in river restoration and management for over 20 years, and he loves fly fishing, healthy rivers, and happy fish. Nat, the floor is yours.
Thank you, Yurena. Can you hear me, everybody?
Yes, we can hear you very well.
Okay, great, and we can see the screen.
In presenter mode, Nat.
I'm in presenter mode. Okay, looking good?
Yeah. Maybe you want to share the other screen.
Oh, okay. Try that. All right, thank you. Very good. Okay, everybody. I'm Nat Gillespie. Are you seeing the right presenter screen?
Yep.
Okay. So I'm with the Forest Service, and it's so great to be with you here today. So thank you again, Herman. So I'm going to give you some information about what is the problem with culverts and road crossings. But before I do, we need to recognize that culverts are essential to our world, to everything we do. We drive to the places we go, but they cause serious harm to fish and to aquatic biodiversity, and they impact human safety and communities. And therefore, if we want to have rivers full of fish, we absolutely have to mitigate culverts. So what is a culvert? It's a pipe. A culvert is a barrel or a conduit. It is a type of road crossing that transports water underneath the road. And culverts come in all shapes and sizes. Road crossings and culverts can be small and inexpensive. They can be large, very complicated and expensive. They can be rectangular, oval, or pretty much any shape. But what is important to know about road crossings and culverts is that typically they use a hydraulic design. And what this means is they are built to transport water through the road stream crossing. They are not designed for fish passage. They're not designed to move sediment from upstream at various water levels.
Yeah.
And we know that streams are dynamic. And so streams are constantly moving sediment down from the mountains to the ocean. And what you can see here is that a culvert on the left, hydraulic design, when it was installed, it provided fish passage. But the fact that most of these hydraulic designs squeeze water through the pipe, the force of the water causes erosion, and over time they become fish barriers. So you can see less than 20 years later, we have a very large fish passage barrier. So let's think about the aquatic landscape. The river network is mostly built of small streams. You can see them coming into the main channel here. And in fact, the first and second order streams are typically called the headwaters, and they make up roughly 80% of the river network. And on the Forest Service, we manage approximately 350,000 kilometers of streams and rivers that hold fish. But we also manage 550,000 kilometers of road. And so we have an estimated 65,000 road stream crossings, and most of these are culverts in the headwaters. So the reality is culverts are everywhere. You can see from this Google Earth image, the stream network is in green, the road goes from left to right, and in circles in yellow, we have 3 road crossings. Now we know that these culverts are most likely fish passage barriers, just because of the thousands of culverts that we've inventoried across the United States. We've found that between 50 and 90% of all hydraulic design culverts are barriers to fish. And so these 3 streams here in this desert environment are most likely biologically disconnected from the Maine River. And so, you know, being so common, culverts have major ecological impacts. We know that fish need to access all kinds of different habitats for their life cycles. Here, the Chinook salmon, spectacular migrations of hundreds of miles to find the cold water and the clean gravel they need to spawn, to lay their eggs and die, can find a culvert and be stopped in their tracks. You know, fish are remarkable in what they can navigate. This eastern brook trout is fine in very shallow water. It can easily climb cascades and waterfalls. But when it comes to culverts, culverts often have very low water depth. And so a fish like the brook trout may not be able to move through a culvert because of the low water depths inside the culvert. Pacific sea lamprey here have trouble navigating high water velocity. And this is particularly a problem on the inside of culverts where we have a smooth bottom. And so, you know, these fish that have been migrating successfully for hundreds of millions of years now do not have access to most of their habitat because of dams, weirs, and culverts. And most fish, like this incredibly colored Tennessee darter, do not jump. And so when a culvert creates an artificial waterfall or perch, most fish are not able to move up through the culvert. How can they complete their life cycle? So in summary, culverts disconnect rivers and streams. They're either too shallow for fish to swim upstream, the velocities are too fast inside the culvert for them to navigate, or they create this artificial waterfall or perch. And remember, most fish can't jump. So the bottom line is that the cumulative impacts of culverts can greatly reduce aquatic biodiversity through the fragmentation process. And our research has shown that when culverts act as road dams and limit the upstream movement of aquatic organisms, these streams have lower aquatic biodiversity, lower genetic diversity, and smaller sized fish. And of course, culverts impact more than fish. Here we have the largest salamander in North America, the hellbender, wrestling with a water snake. And of course, culverts impact terrestrial animals as well that use these headwaters. So let's think about climate change for a moment. You can see the glacier of Mount Hood in Oregon and the stream flowing off that glacier. And this is the picture of the culvert that was a barrier, which the Forest Service and the partners replaced with a simple bridge and natural stream bottom. So now the salmon and steelhead can access this important habitat as waters warm and the climate changes. But improperly designed culverts, of course, also impact us. They impact communities. And when culverts are too small in their hydraulic design, they're often overwhelmed during these large flood events that we see, and the results can be catastrophic. And when culverts fail, they create not only safety hazards, but they disconnect communities from where they need to go, sometimes for weeks and even months. And when we're talking about climate change, the culvert network that we have makes us increasingly vulnerable to the impacts of climate change. The research that we've been working on with our colleagues shows a very strong link between fish passage and the ability of a culvert to withstand the debris and heavy flood flows with climate change. But fortunately, we have solutions, and that's what you're going to hear about today. And so that's the good news. We can find a place where we have fish passage. We can make the culverts and the road network safe for people and communities, and we can start to deal with climate change that sits in front of us. So I'll end here in summarizing that you're going to learn about some concepts, methodologies, and strategies to deal with the problems of culverts, but luckily you'll see there's a brighter future ahead. Thank you.
Thank you, Nat, for that wonderful presentation that I think has helped us understand better what's the issue with culverts and road crossings and what a serious issue is when it comes to biodiversity, to the communities and to climate change. You can drop your questions to Nat in the chat box and we will address them later. I would like to remind the speakers to stick to the time that you have allocated. And Herman is going to try to ring a bell. I don't know if we will manage to remind you that there is a timing, okay? Let's move now then to our next presentation. In this case, it comes from Wales. Carlos Garcia and Steph Janukowski from the Swansea University are going to tell us what's happening in Europe when it comes to culverts and road crossings. Carlos, before you start your presentation, will you please very shortly introduce yourself and your colleague Steph? Thank you very much. The floor is now yours.
Yes, thank you so much, Yurena. Can you hear me well?
Yes, we can hear you very well.
Okay, so my name is Carlos Garcia. I'm a professor at Swansea University, and I was fortunate enough to work on the Amber project with many people who are attending the webinar today, particularly with Herman and with many others. During the Amber project, we set ourselves the task of mapping for the first time the distribution of barriers across Europe, because there was a huge knowledge gap that we wanted to address. And I'm going to summarize for you some of the results regarding culverts in Europe based on that study. So, is it going to be death by a million pipes? I'm going to give you an overview of what we know about culverts in Europe and also about what we don't know. So first of all, let me just see if it works. Okay, so what is the defining characteristic of rivers? I think that we would all agree that what defines a river is that they are meant to flow. That is what rivers are supposed to be doing. We call them running waters. Unfortunately, in Europe, like in many places around the world, that's no longer the case. And most rivers nowadays, they just don't flow, at least they don't free flow. And of course, that is a problem because, they, as you know, some of the most endangered ecosystems on Earth, and ensuring continuity is key for their survival. So you will be forgiven for thinking that it is the big dams which are the cause for this fragmentation, but that's not actually our biggest problem. It is certainly not the only problem, and in many cases, it's not the biggest one at all. The big problem we face in terms of fragmentation are what I would call the nasty six, and that reminds ourselves about the use we make of rivers. We use rivers for generating electricity, but also for drinking, and we build dams to do that. We drain rivers when they are not convenient to grow crops sometimes or to plant trees. We divert rivers so we can be used for irrigation. We tame rivers when they pose a flood hazard. We bury rivers when they stink and they are no longer nice, but we also cross rivers. And this is the ones that we are going to talk about now. The structures that we build in order to cross rivers, and those are fords and culverts. And I'm going to concentrate on culverts. Okay, so I think Nat has summarized very nicely what is a culvert, but let's just remind ourselves that those nasty six Three are so-called ponding structures. Those are structures that are going to store water, okay? And those are weirs, sluice gates, and dams. And three have nothing to do with storing water. We call them non-ponding barriers, and those includes ramps and bed seals, but also culverts and forts. So culverts are non-ponding structures which are built in order to negotiate a river road crossing, as Nat explained. So how many are there? How many hidden culverts are in Europe? Like, for example, this one in a picture that you would be very hard to identify. You didn't know it was there. Well, the short answer to that very important question is that we just don't know. Okay, so we don't know. We just don't know, and this is an important consideration, but we must be very clear here. We don't know. So what do we know? Well, what we do know, sort of, is that there is in excess of 1.2 million barriers in Europe. Okay, and we have always said in excess because our estimates are very wide. It could be up to 3.7, so just under 4 million barriers. Okay, and that depends very much on what the length of the river network is, which is something we don't really know for Europe. There are no detailed river network data across the whole of Europe. There are very, very accurate data for countries and regions, but not one that we can use across Europe. So when we say that there is 1.2 million barriers in Europe, that's an absolutely minimum estimate, and it's very likely that that's an underestimate. So how many of these are culverts? Well, one thing we do know is that of the old structures that we have mapped, structures like culverts and forts and river road crossings are the ones that have the highest underreporting error. Those are the structures which are more likely to be missed in inventories. Those are the structures for which our estimates are more of an underestimate. In the atlas that we built, that we compiled, we identified across the whole of Europe just over 111,000 culverts. But we know that's a big underestimate. It could be much higher than that. So we know that because now, thanks to volunteers all over Europe and also increasingly in other parts of the world, they are starting to use our barrier tracker, which is an app that anybody can use to start recording and identifying these barriers. We know that volunteer citizens are telling us culverts are everywhere. They have recorded, was data from a couple of days ago, just under 12,000 barriers, 16% of which are culverts. In some countries, like in Denmark, people are telling us over 45% of the barriers they are discovering, they are culverts. In Norway, it's also over 40%, in Ireland, everywhere. Culverts are everywhere. Now, the problem with this, of course, is that this data is extremely useful, but this has not been collected systematically. We don't know how far or for how long volunteers were out there detecting barriers. So this data is very useful, but we need additional data in order to come up with more sensible estimates. So what we did, my colleagues walked just over 2,700 kilometers of rivers in Europe. They surveyed 147 20-kilometer reaches all over Europe. And what they found is that in just 1,600 barriers that they detected, just 4% were culverts. However, if we actually look at those test study reaches, which are first and second order streams, we find that culverts are almost 50% of the barriers. So again, culverts are not randomly distributed. They are only found, as Nat explained, in the headwaters in the low order streams. And the results of exhaustive, comprehensive field surveys, like the one that we have undertaken here in Wales, in the River Avon, where my colleagues have walked the entire length of the whole catchment, they demonstrate this very nicely. As you can see, on the left goes distance from headwater to the mouth. And as you can see, the culverts are all very close to the source, very close to the headwaters, in places where the mean stream order is about 1.5, 1.3, in comparison with, say, for example, ramps or weirs, which are built much, much lower in the system. So culverts are not everywhere in the water network, in the river network. They are in the headwaters, and in the headwaters, they are actually the dominant barrier. They can make up roughly 50% of the barrels that you find there. Okay, so how do we estimate the number of culverts? How can we possibly try to estimate how big this problem is? Well, one way we can do this is by obtaining reliable data on culvert density and multiplying it by the length of the river network. So basically, you take a study ridge, you identify the number of culverts, say 20 kilometers, and then you scale it up. The problem, of course, is that this is subject to bias, is subject to sampling error, and the combination of two sampling errors make our estimates very, very uncertain, very unreliable. But we have tried. And if you remember what I said, that in the atlas there was just over 111,000 culverts, when we actually apply these correction factors, we come up with estimates like 240,000 or 143,000, depending on which correction factors one apply. But of course, this is in a way based on something which we know is wrong, and this is based on the assumption that culverts are everywhere. But we know that's not the case. We know they're found mostly on the headwaters. So what would happen if instead of using these estimates for the whole of Europe, we just concentrated on the headwaters? Well, the length of the river network in Europe is about the total length, is about 5 million kilometers, 80% of which are first and second order streams. And if we were to use the density of culverts that we have found in the field, just in first and second order streams, one would come up with an estimate of more like 500,000, 500,000 culverts. That's more than twice our previous estimate. Okay, but obviously this is a very rough estimate. Perhaps another way we can try to tackle this problem, this big question, is by looking at other ways of estimating the culvert density. And one way that my colleague Barbara during the AMBER project they did was to look at the density of river crossings. And we found that that was a reasonably good predictor of barrier density. Now, Europe has some of the highest densities of roads anywhere in the world. And you may be surprised to discover that for every kilometer of river, there is almost 4 kilometers of roads in Europe. And some places where the rivers are absolutely crisscrossed with roads are Germany, they are the Netherlands, also the UK, and also France. Some of these are very, very high estimates. So if we were to use this method instead of using the field method that I outlined before, one could reasonably come up with an estimate which is under 1 million culverts. Obviously, this is a very rough estimate. It would imply that places like France may have over 150,000 culverts, Spain 100,000, Sweden 86,000, and so on. So it's a big, big number. Obviously, the uncertainty is high. Is this a reasonable number? Well, my colleague Steph, who will speak next, has estimated that for the UK, for Great Britain, they may be about 50,000 culverts. We have just estimated that number may actually be 59,000. In the Great Lakes, which is about 20 times smaller than Europe, it has been reported there are 250,000 culverts. So it may not be that unreasonable to find this sort of hundreds of thousands number for Europe. Germany has 51,000 bridges. So perhaps 96,000 culverts is not that unreasonable. And the same for France. France has, nobody knows for sure, but it has between 200,000 and 250,000 bridges. So perhaps 150,000 culverts might also be reasonable. So it doesn't really matter what the actual number is, and it will take us, a lot of work and research to actually get more precise estimates. But what is clear is that culverts are very numerous. What can we do in addition to removing them and retrofitting them, which is the subject of our talks? Well, I'm going to suggest we can do 3 things. First thing we can do is to plan our roads more carefully. I was very shocked to discover that the growth of the motorways in Europe has grown exponentially just in the last 20 years. We now have almost 2 million kilometers. This is just motorways. And of course, more motorways, probably mean also more roads, which means more river crossings. So one way that we're never going to win if we continue crisscrossing of rivers. The way that we can win, that we can reconnect our rivers, is by halting, stopping, fragmenting them. And that perhaps can be done by rethinking how we plan the way we design roads. And I'm just going to very quickly take you four possible scenarios. This is a typical sketch of a stream. The headwater is up in the stream. The mouth is at the bottom. So if you were to build a road in the headwaters, this is what might happen. If option one, if you wanted to go from left to right, by doing it there in the headwaters, you are going to crisscross, you are going to intersect the river network 8 times in this example. See what happens if you move the road a little bit out of the system. You are still intersecting it, but that has reduced the number of potential problems considerably. Now, instead of having 8 intersections, you have 3. If we apply the same argument and keep coming down, it comes to 2 intersections, and obviously the preferred option would be don't cross the river in the headwaters, cross the river closest to the mouth. Okay, and likewise, the other thing that we can do is perhaps start considering how we can decommission abandoned forest tracks, roads which are no longer in use, and how we can apply some sensible rerouting of existing road networks in order to minimize the number of crosses. And the third thing that we can do, and I finish now, is that perhaps it's time that we make more effort at raising awareness about this problem. And one way we can do that is by actually changing the name. And perhaps I'm going to suggest that instead of calling them culverts, perhaps we should call them culverts. Why? Because they are 90% invisible, yet they are visible. Thank you. Over to you, Yurena.
Thank you very much, Carlos. I understand then that Steph is not going to make any contribution. Are you going to say something, Steph, or not?
There she is.
Hi, Steph. Because it was my understanding that you were going also to participate in this session, or should we close it with Carlos' contribution?
Steph, can you hear us?
You can hear us? We cannot hear you. I think that you are muted. Yes.
That was magical.
Yeah, now.
Yeah,
now we
I
can
have a
hear you.
video. I have a video. So
Good.
Okay.
So go ahead. That's perfect. Brilliant.
Yeah,
Okay, let
maybe
me
introduce
share my
yourself.
screen.
Steph, maybe introduce yourself first, because I think you're a colleague of Carlos. Maybe just introduce yourself and then show your video.
That would be nice.
Sure,
Yes.
Herman. Okay, thank you both. Hi guys, so I'm Steph Janikowski-Hartley, and I'm working with Carlos here in Swansea, and also here with me today is Daphne Yanalatu, Rochelle Bristol, and Maren Thomas, who are working and helping on a lot of this work about culverts and other road infrastructure that we're looking at here in the UK. So I'll just start the video because we talk about it there. So here we go.
Steph.
Can you hear it?
Yeah, you have to stop for a moment and you have to go to the right side. There is a button where you can, in the Zoom, where you can share the sound of the video.
Got it. How about now?
Not yet, no.
Okay. One more time.
And there's the button before you share that says maximize audio and video, just before you share.
Okay, let me stop sharing. Should I, or keep sharing?
Yes,
Unshare.
stop sharing. Stop sharing and yeah.
I'll try again. Okay, optimize, share sound, optimize for video.
Yeah.
And no?
Increase your sound.
It's there, quiet though. Turn up your volume.
Yeah, it's turned up.
Oh,
Okay.
On the left side, there's the sound bar below.
Yes.
There. How high is it?
Okay, I see.
Yeah,
Okay,
there
let's
it
try that. Let's try that. That volume is there. Okay. Hi, I'm Steph. In this short video, Fire Lab team at Swansea University share about our efforts to find and attribute culverts like this one just behind me. So let's dive in. When our project started in 2018, there was no openly available inventory of road river crossings for the UK. Addressing this gap was our first goal, and we mapped over 110,000 crossings in Wales, Scotland, and England. As you can see in this map, right here. With road river crossings mapped, our next goal was to attribute each of them as either a culvert, bridge, or a ford. And now here's Rochelle.
Firstly, the satellite imagery and the existing spatial data, which are streamlines and the locations of road river crossings we don't know the types for. I then zoom in and along a streamline until I find a road crossing mapped by a yellow pin. Once at the pin, I zoom in as far as I can and visually assess the structures at the location. It is most often a culvert, a bridge, or a ford. Once I identify these structures, I map the corresponding marker, and that's it. I will then continue along the streamline to the next river road crossing. Sometimes the imagery is low resolution, or there are trees covering the structures like this one here. In such cases, I use the corresponding marker and map the location that's not clear. A second person later visually assesses the location, and we aim to map all structures as a culvert, a bridge, or a ford, not leaving any not clear points. Eventually, the satellite imagery is full of coloured pins, and we have attributed the road river crossings. This data will be part of a large river obstacles database for the United Kingdom.
Thanks, Rochelle. To date, we've attributed nearly 12,000 road river crossings in Welsh catchments, finding that most are culverts, and you can see those as orange dots on the map. We found that nearly 70% of culverts in Wales occur on the smallest river reaches. You can see them in pink there on the map. This pattern is similar to most other regions in the world, and in Wales, we know this is an incomplete picture, limited by what the spatial data could capture and missing those crossings where the smallest streams cross the smallest tracks. Culverts and small streams are vulnerable to failure because they're often situated outside built-up areas and in steeper terrain, and the status quo is that these culverts are poorly installed and maintained. But what do these culverts look like in Wales, and what attributes might indicate these structures are impacting nature and possibly people? Well, we're in luck, because today our culvert correspondent Carrie is streamside and ready to get her feet wet. Oh, careful not to slide in there, Carrie. That looks like an eroding stream bank. Looks like Carrie is at the inlet to the culvert. Carrie, that culvert looks tiny. Could you slide through it? Any sediment or rocks in the culvert? Carrie, can you use your arms to show us how wide the river is there and how much of that width the culvert occupies? Do you think the fish on your shirt could swim up this culvert, Carrie? Is it too steep? What about the condition of the structure, Carrie? Can you point to any structural deficiencies where it might be cracking or eroding? What about downstream? What does the outlet look like? Oh, what do you mean? That's the best you can show us? Oh, there's a fence and the landholder won't let you onto the property? Oh, wait. It's our correspondent, Daphne. She wants to add something. Please stand by, Carrie.
Hello, Steph. Hello, Kerry. How are you? Well, while you're visiting a culvert, it is important to consider that these structures contribute to our visual culture and aesthetics. The design and replaceability of any material or structure like culverts influences our appreciation of them, our willingness to maintain them, and our commitment to improving them. Just one more thing to consider about these culverts. Now, back to Steph and UK. Bye.
Those seem like important things for us to consider for human well-being. Thanks very much, Daphne. As Carrie has shown us, collecting information about and monitoring culverts is time-consuming and so can also be costly. We require creative ways to address this challenge around the globe.
Yay!
So where do we go from here? Here's Maren with some ideas.
Hi all. So you see the picture behind me? Do you think a fish would pass through this? What fish, I hear you ask? Well, that's a good point. And this is just one of the things we need to think about when assessing the passability of a culvert. Can you do me a favour and take a few seconds to look at the following pictures and think about what you might need to take into account when assessing whether it is passable or not? Okay, so here goes. It's a quick fire round. What about this one? Passable, not passable? Why? Why not? What are you thinking of? What about this one? And what about, if you can find it, this one? And finally, what about this one? This one's my favourite, but not very possible. To find out, we're currently designing a survey to explore these things and need experts such as yourselves to get involved. So watch this space. In the meantime, I will pass you back. Thank you very much.
Thanks, Maren. What do you think, Carrie? I think that covers it. Thanks for your field correspondence, Carrie. Enjoy your culvert capers. And thank you all for joining us today. May the fish be with you.
Wow, what a lovely video, Steph. Thank you so much for sharing that. Thank you, Carlos and Steph, for this insightful exposition of this issue in Europe and sharing with us the amazing work that you are doing. Carlos, I love the nasty 6 slide. And I have to admit that I am shocked with the new numbers and the estimation of culverts in Europe. Steph, again, the video is lovely, extremely informative and funny. Thank you so much. Let's move to our next point in the agenda. Now we are going back to the United States to learn what is a stream simulation and how can this help freshwater biodiversity and river ecosystem functions. Our next speaker is Bob Gubernik. Bob is an engineering geologist with the USDA Forest Service with 36 years of experience assessing and designing aquatic organism passage structures like culverts, bridges, fishways. He provides technical assistance and training across the US, and he is a principal author, a developer, and an instructor of the USDA stream simulation methodology. The floor is yours, Bob.
I'm trying to get the share for my screen here. So let me.
We can see it. We were able to see it.
You were able to see it? Okay, because I
Yeah.
wanted to get to share presentation view.
It was fine.
It was fine before, so maybe you do the same, exactly the same thing you did before.
Okay, I'm not seeing it on my screen though. There we go. Presentation. There we go. Can you guys see that?
Yes. However, you have to click on display settings, and I think that you have to choose an option that, because we can see your notes, and I suppose you don't want that to happen. There are two options, I think, under display settings.
Can you see it? I switched it.
Now, yes, perfect, brilliant.
Perfect. Okay. Good morning. Sorry about the technical difficulties, everybody. I'm just going to launch in to it. I'm going to be talking about stream sim principles and applications in the United States. I'm Bob Gubernik with the National Stream and Aquatic Ecology Center. I'd just like to acknowledge a few of my colleagues, Dan, Mark, and Nat, who have helped bring stream simulation to the forefront in the United States. And I'm going to give you a few definitions, why we do stream simulation, and then some stream simulation design methodology. So with that, we're going to launch into stream simulation design method. Stream simulation design method is a channel that simulates the characteristics of an adjacent natural channel that present no more of a challenge to the movement of organisms than the natural channel. It can also adjust vertically through time. So here we see a stream simulation structure on the left. The reference reach is on the right, and then on the right is what that looks like during bankfall. The reference reach, that's the principal thing that we're going to be copying. A reference reach can be found in every stream type and geomorphic context. The reference reaches are found either upstream or downstream of the structure, and they provide the channel dimensions, the material sizes, the grade controls, channel units, etc., that are used to configure the channel as a crossing with similar attributes. It is the stream segment that is copied and emulated to develop our design. So bankfall width, that is a significant width as far as hydrology goes, and it's the width of the location where the channel begins to spill on the floodplain during
Oops, is that just me or we lost Bob?
I think we lost Bob.
Yeah.
He was too enthusiastic. We have to find Bob again.
Yeah, maybe what we can do while he gets in again, we can move to the next point. What do you think, Herman?
Shall we give him
2 minutes? 1 minute? Yeah, okay.
And let's see if Mark, maybe do you have a phone number of Bob? I see Bob again. He is back, I think.
Good.
I'll give him a call as well.
Can you guys hear me?
Yeah.
Yes.
Yeah, the computer.
What happened?
Yep. Okay. So getting back in here, sorry, technical difficulties here with the internet. Bankfall width again. That's the minimum channel structure
Bob?
size that we're going to use. Yes.
Bob, we cannot see your presentation. You will have to share it again with us.
Okay. And where is this? Come on, where are you? It's, for some reason, it's not coming back up again.
Shall we perhaps first move then to the interview and then you try to reinstall it, perhaps?
Yes. Let me try to join the meeting again.
Yeah.
Brilliant. That's perfect.
Nicole, can you bring in Luke? I hope he's ready.
Yeah, so now let's move to what was planned for the next point in the agenda, where we were supposed to take some fresh air and go to the UK, where we are going to learn a bit about a project that is called the Culverting project in West Cumbria. But I will let Herman to lead this section and find out more about the project. So go ahead.
Yeah, I would like to make sure that Luke is ready. So is Luke ready? Nicole, can you get Luke on board?
Yeah. Can you turn your camera on so I can spotlight you?
Yeah, I think I have. This is Luke. I don't know if you can hear me.
I can hear you. Just 20 seconds. I'm going to show where you are, Luke. Here we go.
Okay.
Let's see where he is. Oh, here we go. All the way to the UK. West Cumbria. Here we are. Okay. Hi, Luke. How are you doing? Where are you?
I'm good, thank you. Yeah. Hello, everybody.
Hello.
thank you for joining us out here in West Cumbria.
What are you doing there in West Cumbria? Where are you standing?
Well, we're on behind me. You can see the fringes of the Lake District National Park, and we are we're very close to the Irish Sea, where the rivers of the Lake District flow out into the sea here. And what we're stood on now is a fairly flat, fairly traditionally maintained field that has had a kilometre, so, well, almost 1,000 metres of culvert installed right underneath where I'm stood to enable field drainage and surface water to get out underneath the field so they can farm on it.
Okay, what kind of culvert is it? Is it like it's like a kilometre long and closed off?
Well, I'm just going to walk over to where the best area to show you, and you'll be able to see that it's a pipe underground. It's about 500 millimeters, and it's fairly consistent. And the problem with that is obviously the kilometre of river around 100 years ago was completely buried and hidden away so that it could aggravate the farming.
What's your plan to do? What's your plan to? What kind of solution are you thinking about?
Well, what we're going to do is, following approximately the channel you should be able to see now, you can see where we've had to dig in to do some exploration and practicing, working out where the pipe is. You can see the width of it, and in the distance you can see where it opens up. We're going to open up this entire channel. So the measurements, as we're stood looking at them, we've got 985 meters of buried channel. And what we're going to do is open it into a new river section for 957, which equates to 97.5% of that kilometre is going to be opened up and put back into a new open flowing, more natural river.
Okay, and what was the main driver behind this? What was the main reason to do it, and who are you cooperating with? Are you cooperating with other organizations?
Yeah, so the main driver is salmon and trout habitat. This would make a really good spawning habitat, mainly salmonids, but other fish species. And as some of the earlier presentations were talking about, it's not just the fish, it's the wider habitat and ecology that will benefit from having natural streams instead of buried channels. We've been doing this project, we've been working on it for about a year, primarily with the UK's Environment Agency. So that is the government body that helps with the environment here, and they are funding this project and working with us as a partner through a really great program that we're involved in called the Cumbria River Restoration Program, which, as the name suggests, is looking at ways of improving river and riverine habitat, not just here in West Cumbria, but all across the UK.
So there is a big scheme for culvert restoration, or is it like more a wider river restoration project with removal of dams, weirs, and culverts? It's a complete package?
Yeah, it's both actually. So when it started, it was mainly focusing on rivers and things like remeandering, sort of 10, 12 years ago, but it's now opened up into anything that will improve habitat and ecology. So as we walk around this site, and I'm going to take you back up to the start as I'm talking, we've started to work on barriers removal, anything that could connect Maine River to the upstream habitat. So see, one of the problems here in West Cumbria is a lot of these channels have been blocked by farming practices, so that farmers need to make best use of the land, and that's understandable, but it isn't necessarily the best for the river habitat. So we've developed the barrier removal program, and that's what the Environment Agency are helping to fund, so that we can open up these channels and connect the upstream with the downstream habitat.
Very cool. And can you show us the road, perhaps, or how much further do you have to walk?
Not far. I would run, but I'll probably make you all travel sick. So I'm just going to show you now where it crosses underneath the road, and we'll be able to see the size of the channel and the way that it is impacted by, as I say, traditional farming habitat here. I'll walk up here as quick as I can without running.
Okay. Hey, and originally, I think there was a plan to have George on board, your colleague. Is he around?
Yeah, unfortunately, he can't make it. So I've got a couple of pictures to show, which is just where I'm walking to now. And I can quickly talk about some of the other benefits of this project.
Yeah,
So you'll see the gravel pile. This is what's been taken out of this trough here. And if I speak up over the water, you can see where it crosses underneath this main road. There's a lot of cars here.
Okay.
That's the main culvert underneath the road. And then it disappears underneath this grid system here, flowing down into the distance. So we will create from here a really nice new channel, a new habitat. But crucially, this is very basic of me and I apologize. I can show you a picture here. These are some of the wetlands further down that we're going to be connecting into the main river. So on the right-hand side, you can see the River Cocker, which is a really important salmon fisheries for us. And you can see that mosaic of wetland. We will be connecting into there so that those field systems allow the water to get out and will help, well, it will help farming, but it will also help the habitat here. And this is just looking at the scale of the project. I'm stood, where am I? About half a kilometre behind here, and the new channel will be running, follow my finger, into these wetlands and connecting up to the Cocker there.
Super, Luke. This is a great explanation of what you're going to do, and I think it's inspiring to see that you are opening up a culvert of 1 kilometer.
Yes.
So, do you have a last question, Yurena, before we?
Yes, I see that, and in the chat there is a question from Francisco Martinez. Can you tell us the municipality where this is taking place? Are you near the coast?
Well, as the crow flies, we're about 7 or 8 kilometers from the coast. So, well, how do I explain it? In front of me now is the coastline, and then behind me in the mountains there, that's part of the Lake District National Park. So this channel here will directly feed into the Cocker, and then the River Cocker will flow out, as I say, about 7 or 8 kilometers into the coast. So it's one of the first options for, you know, migrating salmon to find kind of sheltered backwaters for spawning.
Mm-hmm. And I see another question. Can that stone culvert be backwatered, built up to make it more passable?
Yeah, that's a good question. That's exactly what we will do. So in this project, in phase 1, it's going to be too expensive to start interfering with the road, and we'd obviously need to bring in the highways agency as well. But we will build up a step pool system using interlocking stone that will reduce any height drop so that there is an easier passage from this channel now through the field underneath that road culvert and then further upstream. So it will be built up with the pool system.
Amazing.
Thanks, Luke, for this great explanation. And we have the webinar is visited by more than 600 people, so you have a lot of visibility now.
Excellent. Can I, have I got time just to very, very quickly say as well, in that channel, which I'll just turn around and point to, we were electrofishing nearby in the summer, and we managed to quickly just see what was in here, and we found 12 fry and 8 salmon parr sat in here. So this is 700 meters in a direct line from the river. And we found salmon and trout parr in here. So we know that this will become great habitat once it's better opened up for access.
Thanks, Luke. And hope to see you in real life soon again.
Yeah, me too. Thank you very much.
Yes. Thank you.
Yeah. Thank you. Thanks, everybody.
Thank you very much. I think that we have Bob back. Are you, Bob, available? Are you there to continue with your presentation? I think you are, right?
I am. I'm going to share my screen.
Good. Let's go.
What screen are you guys seeing?
We see your screen, we see your presentation, so everything is perfect.
Perfect. Okay. I'm going to go through the stuff that I have already done and get to the next slide. So we're at flood resiliency. Again, that's a structure that's going to be able to survive a flood that's greater than what the structure was designed for. So in the US and essentially in the world, we've had an evolution of design methodologies for aquatic organism passage. You know, at first we didn't have hardly any consideration for AOP. Then we moved into using bare pipes and backwatering them for passage. Then we started to add in different appurtenances such as weirs and baffles using the hydraulic design method. So the hydraulic
Oops, I think that we have lost him again. Let's see, a couple of seconds and what happens.
I'm going to try to bring it on the screen, the presentation of Bob. See, let's see if Bob's still there. Bob, can you unmute yourself? Bob.
Hi, Bob.
unmute. Hi, can you see me?
Bob,
what happened?
It happened the same thing as before. So we lost you.
I'm gonna show the slides now. So you have to unshare. Do you see my slides, Yurena?
Yes.
I don't see anything there. Okay, so Herman, go to the evolution of. That's it.
Herman is going to.
No, too far. Too far.
Which number? This one?
That one. That one. Yep. Go into a presentation mode on there.
Yeah.
So, as I was mentioning, the stream simulation is flexible because in the bank full channel that itself, it's invisible to the fish versus the hydraulic design, which are a rigid structure. So if the stream moves a little bit and degrades downstream, now that structure is perched. So knowing these differences and where we've come from a historical sense, the Forest Service has decided on an order of precedence. We do stream simulation first. If we can't do that, we go into a geomorphic design, which is essentially the same thing as stream simulation, except it's out of context with the stream. It may be steeper than what you find in the stream channel. So the geomorphic design is actually a natural hydraulic design, and then you go into hydraulic design. Next slide, Herman. So the main reason why we went into stream simulation was for aquatic organism passage. And this chart here shows spawning intensity for a number of different life stages and species in the stream itself. Now, if you have a hydraulic design, you're limited to a certain range of flows for a certain species typically. And if we're trying to make sure that the entire aquatic assemblage is passed, we needed to do somewhere else. So we went into stream simulation design methodology. Next slide. Another reason is climate change. There's a lot of hydrologic uncertainty out there as far as what our flows are. We know that we've been seeing significant increases in the larger storms, and in some areas, increased precipitation throughout the year. In these two charts here that you see, the one in the lower left-hand corner shows the number of 3-inch storms in a year on average, and you can see an upward trend there. And then if we go into regional aspects in the upper right graph, we can see that there are some parts of the US that are experiencing huge amounts of heavy precipitation that have increased from historic amounts. Next slide. So where it comes home from a stream simulation standpoint for us is that we're getting these huge floods and more frequent floods, and they're hammering our structures. And the one major benefit that we realized by going to stream simulation, not only was it a passable to all the aquatic organisms, but there was a flood resiliency aspect. And in this example here, this is one of the structures that survived a 500-year flood in Vermont. And you can see the pre-flood pictures on the left and the post-flood pictures on the right. Yes, there's been manipulation and changes in the channel bed. There's been some minor scour, but you have passage for all organisms still, and you don't have any maintenance or repair required. Next slide. So what does that mean? That means that when you use stream simulation, you may have a higher upfront cost, but in the long term, what Nat and the rest of the team have found is that, typically we're only 9 to 22% more in the upfront costs, but the research in the long-term costs are, it's cheaper. So in the long term, you pay a little bit more money upfront, but in the long term, it's much cheaper for us, and our infrastructure essentially is being flood-proofed by our stream simulation design methodology. Next slide. So let's take a look at the fish's view and the water view of these structures. So here's a hydraulic design methodology. Essentially, we're building a dam with a small orifice in there that's capable of passing water, and maybe a little bit of sediment and some fish some of the time. So when you're going through there, remember that discharge is equal to velocity times area. So these hydraulic designs are much smaller orifices. And then think about what this thing looks like at flood with debris coming down. This is a recipe for failure. Next slide. So as we go into stream simulation, the natural channel, there's no constriction within the bankful limits. We are passing water also on the floodplain if there's a high conveyance. So the fish don't see any difference really from the structure to the stream itself. It's also a flexible design, meaning that as the bed changes, if you recall some of the photos that Nat had in his presentation showed some bed elevation changing at the outlet. In this case, if that bed went down, it would not become a perched barrier like you saw on the bare pipes. Next slide, please. So I'm just going to go over essentially phase 2 and phase 3. That's the site assessment and stream simulation design. We go in through a lot of these, but due to limited time, we'll just talk about those two. Next slide, please. So the initial assessment is the large scale view. We're looking for, do we see any geohazards there? Can we move forward stream simulation design? Stream simulation design is a great design methodology. It can't provide solutions for every single road stream crossing. Things that you need to be concerned about are road impounded wetlands because they are sediment sinks, unstable streams. No matter what design methodology that you have to use, unstable streams are problematic. Also, streams with a lot of high debris flow coming down, as you can see in the upper left-hand corner. You may want to use a different structure configuration and design methodology. Next slide, please. Then we go into the site assessment. And our main purpose for that is we're trying to understand the stream. We are trying to find a reference reach to copy all the different metrics that we need, the channel width, the bed width, the sediment sizes, etc. So we'll go into some of the parts of that. Next slide, please. So the first thing that we do is we go into a stream and we do a long profile survey and do a long profile analysis. And what that does is it segments the stream reach into different channel gradients based on grade controls upstream and downstream of that. And one of those segments is going to be our reference reach. And we measure the heck out of the stream in those reference conditions to come up with those metrics. Next slide, please. Then we go into measure the cross sections. The cross section essentially is going to define our beginning width, which is going to be the bankfall, plus our banks or margins, the shape of the channel, and our cross-sectional area. And we're going to bring those for the different channel units into our design itself. So when we're doing this, we're going to take a complicated cross-section or set of cross-sections and turn them into more simplistic from a constructability standpoint. Next slide, please. We review and measure the channel bed materials. So in the analysis of those, we measure the particle sizes and distribution of the surface particles in the stream bed. We do a visual estimate of our subsurface materials to determine a rough percentage of sand because it's meaningful in our development of our gradation. We measure the key pieces, grade controls, things like steps, boulder, clusters, wood that protrudes into the dimensions for channel roughness. We get the cubic dimensions, the sizes, the spatial distribution, the protrusions of those. Because again, what we're doing is we're going to copy this reference section and use that as our design template within our structure. Next slide, please. Then we go into looking at the risks. There are 5 risks that we look at and consider during our stream simulation design. Of course, first one is channel stability. If we are on a highly unstable channel, we may decide to use a different methodology. If there's just minor instabilities, we can completely use stream simulation. Next slide, please. Then we look at the vertical adjustment potential. And what that is the fluctuation in the bed up and down in the stream. Typically, when we have small orifices at our structure of the existing structure, there is typically a sediment wedge that is upstream. And we need to determine what's going to happen to all that material in the design. So understanding where deposition may occur, going downstream, understanding how far up a head cut might go. Again, these are all needs that need to be addressed during design. Next slide, please. Next is the risk of head cut. Trying to understand in a stream, if a head cut is initiated, how far up will it go and what are the ramifications of those? So here we see in a photo, this photo is down in Mississippi, and the downstream section has undergone incision because the entire Mississippi basin is lowering stream channel wise because of things that we have done for navigation and flood control in the Mississippi River, and it's propagating up to the system. So in this case, we have a downstream that is one elevation and an upstream, which is a higher elevation. You can see that the upstream channel is protected. During our design, we may make a decision either to allow the incision to go up or to restore some of the downstream reach so we have a usable gradient. Again, you need to understand what the ramifications are for head cut. Also from a standpoint that you may not need to reconstruct an entire stream. You may allow a stream to head cut a little bit and adjust on its own. Next screen. Next one is adjustment potential. You're going to have a structure that's going to be in the ground for 50 to 100 years. How much is that stream channel is going to move upstream? Is it susceptible to large movements? Is there anything that we can do to help attenuate that? Because think about the stream to the structure geometry. In time, if you have a stream that's migrating laterally at the inlet of a culvert, it's going to be offset from the structure and provide poor inlet geometry and potentially start to cause aggradation. Next slide, please. Last one is floodplain conveyance. Depending upon where you are in the watershed and how much water is conveyed, you need to understand that, because as you see in the photo, when the water come up, before it blew out this pipe, it was blowing over the road in a number of different locations. Typically, those are either low spots or they're flood swales or historic channels. When you are conveying a lot of water across a floodplain, you need to pass the majority of that water on the floodplain, or you need to have a very, very large structure, because think about the changes in the shear stress on the bed. If you're focusing all of that water from the floodplain into the structure, your depth is going to be higher in the structure versus upstream in a different portion of the channel, because there's greater depth of water, because you're funneling all that water through one structure instead of using the conveyance of the floodplain and those lateral channels and swales. Next slide, please. So then we go into the design. We know the channel, we have a bunch of reference conditions. We're going to design a profile that ties in two grade controls, a stable one upstream, a stable one downstream, and the gradient of that profile should be within 25% of one of those stream segments that we'll use for a reference condition. So if you have a slope of 1%, then your reference conditions can range anywhere from 0.75 to 1.25% slope. And from here, you're able to pick that segment that we're going to use for our reference reach. Next slide, please. So you have that, you have your cross sections in there. And again, what we're doing is we're building a channel, then we're going to wrap a structure around it. And here you can see many different structure types go over the same cross section. Again, you have to think about how much embedment depth you need, what the effects of hydraulic capacity are on there, your clearance to the road. Again, all these different structures have different criteria that you have to look at from an engineering perspective, also from a loading. Not all of them can take large amounts of fill over top. Again, we're looking at the cross section and wrapping a structure around it. And we're including banks and margins to help control the channel cross section shape, because again, your cross section in your reference reach is a certain shape, and we are trying to emulate that within our structure. So all hydraulic forces are similar within those bank full limits. Next slide, please. So just quickly, some culvert anatomy. Again, you have the culvert height, then you have your depth of your water there. And if you divide your water depth by your culvert height, you come up with a metric, and that's the headwater to depth ratio. Next slide, please. And our requirements for stream simulation is that we want to have at least 20% of the vertical open space available for debris and hydrologic uncertainty. And one of the things that we realized when we went into stream simulation design is that when our structures went to bank full or greater, actually our headwater to depth ratio went down to about a 0.6 to a 0.7, leaving again 30% of the rise available for debris. And that's one of the principal functions of why we're seeing much greater survival during these floods that are greater than a Q100 design flow when it goes through a stream simulation culvert. Next slide, please. And then what we definitely don't want to do is have the water go over top of the culvert. That puts it in a pressurized flow situation, and that's the best way to lose your bed material and fail a stream simulation culvert, is to put it into pressurized flow. Next slide, please. We need to know where the embedment is and get it down below. Again, that's vertical adjustment potential. And we use the stream and the pool depths to do that and apply a fludge factor. Next slide. Smooth transitions in and out of the culvert. We click it again so you can see the transitions there. Herman, it's an there's an animation on there. You got to click a few times for me.
Let me see.
Just go next slide. There you go. So you want to have smooth, that's fine. Go to the culvert picture. Next one. There you go. You want to have that smooth transition going out because we know that rapidly changing cross sections are places where you either hang up debris or you start aggradation. Next slide. And then our bed configurations. Again, we're using the same size materials in similar configurations within the structure itself. And we're using the lengths and the ranges of the pool, riffles, the depths, etc., in our reference condition and fitting that within the two stable grade controls. Next slide. Stream simulation, again, is about equal mobility and stability of materials. You want to have the conveyor belt that the stream is move those sediments at the same flows. If you are different, if your structure is starting to pass sediment faster than what your reference condition is, you're in a degradational mode, and vice versa. You could be in an aggradational mode, again, which is why we're using similar dimensions from our reference reach in our structure. Next slide. The configurations, again, are different in different parts of the watershed. In the upper portion of the watershed, we have incised confined channels. The structure width is the valley wall width. As we go down, we're getting more water onto the floodplain. In the median section of the watershed, typically we still have one structure, but it's larger because we do have some flow that we're going to be taking in from the floodplain. In the very lower portion of the watershed, we have multiple lateral structures because we just simply can't fit all the water through the main channel, and we need to utilize side channels and swales to pass as much flow to keep the shear within the structure similar to what you find in the bed itself. Next, yes.
This is Yurena speaking. You have 1 minute left. We need to.
Okay. All right. Last one.
Thank you.
Is just designed for failure. We know that our structures are going to fail. How you fail is up to you. Create low spots. Next slide. You can see on in the image here, we have a culvert that was blocked, caused $250,000 worth of damage. Create a dip. Use road design. Let the road fail, not your structure. It will be a lot more cost effective. And that's it. Sorry about going over, guys.
No problem. Very good. It was a really nice presentation.
Well, thank you so much. That was really a very comprehensive, complete, and excellent presentation showing us in detail the full process for stream simulation design. Now, before we jump into a short break, I would like to challenge your knowledge a little bit and ask you 3 questions that we could use later for the discussion. And we are going to use a Mentimeter poll. We are going to ask you 3 questions. My colleague Nicole is going to paste in the chat box a link that will drive you to the Mentimeter. It will take just a couple of minutes to see what your answers are. And after that, we will move to a break. Yes, Herman.
Nicole, can you share your screen so that we can see it on the screen?
Yes, doing that now. Okay, and then everyone see the Mentimeter poll?
Yep.
Great. Ruben, could you put the information in the chat?
I think he already did.
Oh, he did. Great.
Yep.
We need a live.
Yeah. Go to menti.com and enter the code 85612854.
Excellent.
Unfortunately, I'm having problems seeing that on my screen. So maybe Herman, you can take over while I solve this issue, because I cannot see either the link or the Mentimeter on my screen.
Okay, it's already working, and I will take over from here then. So everybody's starting to fill in answers. Let me see. Reducing fish passage barriers. Fish climate change is an important reason. Fish passage, everybody's really active. I can't see the link. Can you share the link again, Ruben, in the chat? And if you go to the top of this slide, you can see menti.com and use the code 85612854. Everybody's really active. Really nice to see. Fish passage, a lot of reasons: fish migration, connectivity. The cloud is changing constantly. Yurena, are you able to see it?
No, I'm not. Now I see the link, but I cannot see Nicole's screen. That's what I cannot see.
Oh, that's weird.
Yurena, did you maybe pin another speaker still that you need to unpin first?
I think we can go to the next question because this is. Shall we wait a little bit? Give 30 seconds.
No, you continue. You can continue.
My God, a lot of reasons. Please share, Nicole, the screen like you did just before. Let's go to the next question. Yeah. Oh, it's already working. Okay. What percentage of barrier culverts are mapped in your country or region? Let me see. If you have a problem with Menti, just let us know in the chat and then Ruben will help you. But again, a lot of people already have found solutions. I think I see 159 people are already, 170 people are already filling it in, 185. So a lot of people don't know actually how many culverts are mapped. I think it's more than half of the participants in the meeting don't know, and 26 know for almost 100% sure that they have mapped everything. So I think there is a big challenge to for the participants to maybe start mapping these barriers and see what kind of problems are out there in the field. And can we go to the next question, Nicole? What do you see as the biggest obstacle for removing or retrofitting culverts? You have to like start with the first one, which you think is the highest, and then you go to the second highest, the third highest, which you think is the most important. And 4 people have started to fill it in. Yes, now they're coming in. All right.
And if you chose other, then put your reason in the chat.
Yeah. So a lot of people think cost and funding is the biggest obstacle, but also awareness as a high score. $140 answers by now. Wow, this really works well, Nicole. So if you don't know, if you have something else that you think that is important, then you can put it in the chat. But I think we all agree that cost and funding is the biggest obstacle, but awareness and technical expertise is the third one. So anybody else wants to say something about this? Yurena, are you not able to see it, or are you able to see it?
Yurena needs to be promoted to a speaker again before she can speak. Nicole, would you be so kind?
Yeah, let me do that.
Okay, let's finish up, and we're gonna go back to these answers in the discussion at the end of the webinar. But Yurena, where is Yurena?
Now I'm here. My Zoom just crashed. That was it, and I was not able to speak. But I'm sure that you did it very, very, very well. And now I can see the Mentimeter and everything.
A lot of people filled the answers, and over 260 answers. So that's really great. So this gives a really good overview of what people think is important as the biggest obstacle. And
Totally.
we're gonna come back to this in the discussion.
Yes, and now we are going to take a short break, 5 minutes. We will be back in 5 minutes and we'll continue with exciting presentations and surprises. So see you in 5 minutes.
All right. Yurena,
5 minutes already passed.
We can wait 1 minute more, maybe.
1 minute more, yeah.
I will make sure that the presentation of Sophia is ready.
Good. Yeah. Okay, so I think that we can start. Welcome back again after this super short break. This is kind of a marathon. And now we are moving to Sweden, where Sofia Pera will explain to us how does Sweden deals with culverts and the learning experiences from the live Remivar project. Sofia is an ecologist at the County Administrative Board of Norrbotten in Sweden. She was the deputy project manager of the LIFE Remivar. LIFE is a European environmental program, for those who don't know that. And in this project, over 300 migratory barriers in streams were removed. Now she's working in another LIFE project called Reborn, restoring streams from the damage done by timber floating. Sofia, the floor is yours. You have to unmute yourself because we cannot hear you. Yeah.
Good,
now,
thank you.
Perfect.
No. Okay, thank you. My name is Sofia Pera, and thank you for letting me talk at this important webinar. Although I must say that I'm surprised that this still is an issue. One of my first tasks when I started working at the Swedish National Board of Fisheries was to map road water crossings and migration barriers, and that was over 20 years ago. So the Remivar project started in 2011 and was completed in 2016. The total cost for the project was 8 million euros, half of which was funded by the EU. The project was financed by the EU Commission through the LIFE program, which is an EU environmental fund. And the project within LIFE contribute to improving the conservation status for threatened species and habitats. Next slide, please. Yeah, so let's see. Our objective was to remove over 300 migration barriers during a short period of time, that is 5 years. Next slide. So let me tell you a little bit about my part of the world. I live in the northern part of Sweden. We have a fantastic and wild nature. We have many lakes and rivers that do not have hydropower dams. Many of them are protected by EU and the Natura 2000 sites. Natura 2000 is a network of protected areas covering Europe's most valuable and threatened species and habitats. The northern part of Sweden is a core area for many endangered species, for example, otter, brown trout, salmon, and freshwater pearl mussel. Next slide, please. Fish do move a lot, and they can move up to several hundred kilometers during spawning. Next slide. Cutting species off what they need in order to reproduce is the ultimate form of birth control. Next slide. You might have the best habitat in the world, but if there's a barrier below that habitat, fish can't reach it and they are not able to spawn. Next slide, please. The connection of streams and systems allows for the natural processes that have always occurred and that we disturb with barriers to occur again. So I have now showed you four, no, go back one. So now I have shown you 4 stream road crossings within the Remivar project, and we have remediated 300 more. Now, next slide, please. There are approximately 20,000 culverts and bridges, and probably many more in the water district of the Botnian Bay. Many are on public roads, but more than half are on forestry roads, roads that are built for forestry activity. So we have seen that there's about 30% of all the stream road crossings that are migration barriers. Next, please. So this project has been a collaboration between the Swedish Transport Administration, the county administrative boards of Norrbotten and Västerbotten, the Swedish Forest Agency, and the forestry companies Sveaskog, Holmenskog, and SCA. The Swedish Agency for Marine and Water Management was also a partner. Next slide. So as we all know, this is the problem. And next slide. And this can be the solution. If we build an arch or a bridge instead with a natural stream bottom inside the passage, the water velocity remains the same and there will be no fall at the outlet. Next slide. And now we will try to show a short video. Let's see if you can get it going. Okay, thank you. Next slide. So this is what it looks like before and after. Next slide, please. So we have worked in 5 big catchment areas in Sweden, and all of them are Natura 2000 sites. Next slide. So if you put those areas over Belgium, you can see how big they are. Next. So this is the areas that we have worked in. If we look at one catchment area more closely, the one on the right, you see a lot of dots, and each dot is a migration barrier. Different colors represent different road owners. So when we cooperate, we can get free migration routes within the whole catchment area. Next slide, please. In the Remibar project, we have worked with the rivers, but also small streams. Small streams can be very valuable for biodiversity. This is my colleague. He's standing with 1 foot on each side of a small stream. You can hardly see it. And that contains both brown trout and a reproducing freshwater pearl mussel population. Next slide. As part of the project Remibar, we have actively been spreading information. We have created a website, spread information via Facebook and YouTube. We have reached out to different groups of stakeholders, schools, and the general public by organizing excursions and seminars. Our most popular dissemination activities were the school excursions and family days. And next slide. It is a cost-efficient approach to cooperate with government management, forestry companies, and private landowners. Together, we managed to open up more than 1,700 kilometers of rivers and creeks. That is over 1,000 miles. For example, it is the distance between Amsterdam and Palermo. The best lesson learned is that we have to cooperate. Next slide. So are we done with our work? Herman, please, the film. Okay, thank you. We have done some evaluation of the project, and we have used data that has been collecting in the existing environmental monitoring programs when we use electrofishing and fish counters. So at the end of the project, we already saw positive and apparent trends in the data from some of the electrofishing sites regarding the reproduction of Atlantic salmon and brown trout. Once the remediation efforts have been carried out, it generally takes a long time before it is possible to record any effects on the population. When they reproduce, salmon and brown trout returns to the area where they were born. If salmon is to colonize new reproduction sites higher upstream, the abundance of reproducing adults and the competition for space must be high enough to force some individuals to continue their migration to new areas. In many areas, the competition for reproductive areas is already high, and in those areas, it's very likely that new areas upstream are being colonized. As we can see in this slide, this is one example from Junkaberget site in the Vargeså project area, and it follows the removal of a migration barrier or several downstreams in 2012 as part of the Remibar project. Okay, next slide. So now what? We have a cooperation with forestry companies and other road owners, and we are continuously applying for funds. At the moment, we have 4 restoration projects where removal of barriers is one of the actions. In average, 10 to 20 migration barriers are removed each year in my county, Norrbotten. Next slide, please.
Sophia, if you could start concluding, it would be great. We have 1 minute to talk.
I have just one slide, this one and
Good.
one.
Perfect.
We have also applied for a new life project called Triva. It is in the catchment area of Torne River, our border river to Finland. If we get the funds, 110 barriers will be removed, and we will reconnect over 1,000 kilometers or 620 miles in Sweden. We do not know yet if we have the money. We haven't got it approved from the EU Life Fund yet. And so this is my last slide. If you next slide, please. And this, yeah, thank you.
Well, thanks to you, Sophia. This was a very, very good presentation, and it's great to listen and see all the things that you are doing in Sweden, and also to realize that you are planning to continue, that there is a continuation of sustainability for not just doing this and stop there. I see that there have been a lot of positive reactions in the chat. They loved the videos, so thank you so much and congratulations.
One question for Sophia from the chat. I think it's an important question. The question was, why was it easier to work with multiple agencies over in Sweden? So how was it possible that it's so easy to work together in Sweden?
Why isn't it easy to work together? It's my counter question. We have a long experience working together, and it's not really a problem. I don't know. I don't know.
Okay, thanks.
Maybe that question is maybe so in other places it's not that easy. So
we have worked together for a really long time, and also the staff that are like changing jobs from between the different agencies, so it might be easier for us to work together since we have worked together at the same agency.
Cool, thanks.
Thanks, Sophia. So we are back now in the United States of America with Joshua Roy. I hope that I'm pronouncing correctly your name. From Nature Conservancy, Maine. Joshua will talk us about opening headwaters in Maine. He is part of a global nonprofit, the Nature Conservancy, dedicated to preserving the planet's biodiversity. He brings science to strategic planning and the prioritization of land and freshwater conservation and restoration in Maine and Europe, while promoting free-flowing rivers globally with the World Fish Migration Foundation. The floor is yours, Josh?
Thank you so much, Yurena. It's great to be a part of this, and it's really good to follow Sophia with Sweden, because I'm going to show you a little bit of Maine in our process here, which also started a long time ago, and we asked the same questions. Why has it taken so long when we know there's a big problem? And I think part of the answer to that is awareness and a lot of the things that we're in the Mentimeter poll, but it's also, it takes a while to get momentum on some of these projects and for those collaborations to grow. And in this case, we have climate change, I wouldn't say to thank, and yet it is highlighting where we have undersized road crossings. So let me show you some systemic ways that we have changed this in Maine. Starting with mission, which you heard, our mission for the Nature Conservancy is obvious there. We're all over the world, just real quickly, in about 76 countries right now. And I really think, and I try to work with people around the world on the same message, that these rivers really connect us all. It connects our fisheries to the oceans, improving fisheries that we depend on for food. There are also inland fisheries that are crucially important around the world. And we need to bring awareness to this, and it ties with climate, it ties with energy. I'll get into this more as we go along, but you can see from this map of dams and prioritized dams for the northeastern United States. So there's Maine at the top of the US in the northeastern corner on the West Atlantic. We're about the size of Portugal for scale. And this is showing the dams, and the red dots are those dams that have the best potential to be removed. And so that guided our chapter to join a great collaboration led by the Penobscot Indian Nation to remove dams in the Penobscot, to go from a situation that looked like this with just bright blue connected streams at the bottom to something more like this with 62% of the habitat accessible. But it's sort of missing an important part, which is of course, that there are all these little freckles, these measles all over the map. And once we realized that it was such a problem in this watershed, these culverts, we realized we needed systems to improve the way we look at road crossings, the way we improve them and replace them and build new ones. So as we looked at the problem and talked with partners and networked among people who've been looking at this for many, many years, we realized we need both leverage and this flywheel approach. We need to find specific buttons that need to be changed so that we can affect culvert management around the state. It's not just a watershed approach, it's something we need to do at the very high levels of the state, as well as federal laws around permitting. But we also need this momentum. We need to get it going so that it's going fast enough that it's business as usual. So how do we do that? I think we have a multifaceted approach, much like Sophia's, and something that Luke was talking about in West Cumbria and Steph was talking about in Wales. We need to know where the habitat is. We need to know where the barriers are. We need to analyze these data so that we can focus work, because if you just do lots of little projects scattered all over the place, maybe you'll get there someday. But in the case of Maine and many places, we don't have a lot of time. And with the changing climate and more severe storms, we need to replace the best places sooner, open up the habitat and allow our aquatic life to thrive in the communities around those habitats. We need funding mechanisms, policies, outreach, education, implementation. I'll go through these steps through my presentation. But it started with collecting the data, which was done by volunteers at first. And then we realized this was really the most efficient way, is to train a whole crew at once. It's about 60,000 euros a summer to get them out going. It took them 13 years. It probably would take more like 10 years if we had started with this method. So for about 70,000 euros, you could get these crews out, going to every road stream crossing. Again, as Carlos mentioned and Steph, we have a line on a map. It's not always right for the stream. We have a line on the map of the road. It's not always right. But over time, you get used to looking for these road crossings and identifying them and to get out and survey them. So what have we found? So again, for an area about the size of Portugal, that is, we've got nearly 27,000 crossings. These all come with photographs, which tell an awful lot. Really important for the storytelling part of this. Really important for convincing a road manager. We sometimes find that road crossings are unsafe, and that's critically important to report out because the wooden timbers under the bridge are rotted or the culverts are rusted and falling apart. So we've covered 90%. There's some parts the crew couldn't get to, these last little bits where the road had disappeared or there were gates. But we did find that about half of these are impassable to fish. And this is the breakdown of the entire state. When you've got a big database like this, we have slightly more crossings put into the survey, some were taken out, but you can see 45% of them are culverts. And out of those 11,814 culverts that were surveyed, most are definite barriers and potential barriers. There's very few that aren't barriers at all that are culverts. Bridges are, of course, a lot better. So when we know where the barriers are, and then we can learn where the longest reaches of stream are between those barriers, including natural barriers like waterfalls and dams, the unnatural dams. We also want to look at habitats. So for the northeastern US, this is the last best place for brook trout. So the yellow and green and blue in Maine show the really important areas for this species to persist. It's a cold water species. We also look at other species like our sea run fish. They need to connect to the ocean. So we need to make sure we have connections from the ocean all the way to the headwaters. It's the headwaters that have the most habitat. Something like 80% of the habitat are in headwaters that could be bisected, fragmented by dams. Not all the species go to the headwaters, but there are other species that live exclusively in the headwaters. And it's not just, of course, for these species, but the people that enjoy these areas and for the road systems and for the culture around these areas. So we took all these data, we put them in these prioritization tools. There's a lot of different ways to do this, whether you can do an optimization based on what finances you have to put in, or this is a more simplistic tool that gives you a ranking for every barrier, not only how bad it is for passing fish, but how important it is in the stream network because of all those habitats that we identified and mapped to the stream. We also were able to look at the risk, the flood risk. So much as we heard from Bob Grubernick, we can look at where streams would be overtopped, a road would be overtopped by the stream in a 25, 30-year storm event. And we've seen more and more of those storm events, even 400-year storm events, blowing out one culvert after another, except where we have replaced them with stream simulation designed open bottom arches, and then they have survived, which is a really great lesson, which we ought to write up and share. So here's sort of one of those impacts. These are two different culverts, but you can see it doesn't take much to wash out the sediment once you get that culvert supercharged or full to the top. So those culverts that are bad for fish are often bad for people as well, even for just the 25-year flood event. As we look at these culverts and funding mechanisms, we realize it's not all one source of funding. We need multiple sources of funding. For towns, we would need a different source of funding than the state roads. Hopefully they can take care of their own network. And these sources of funding come from, we've got several US government agencies, and luckily there is cooperation among them. There are opportunities to match funding with certain funding sources. Sometimes private funds come into these. But we're also getting in-kind match from these agencies as they help with the other components of education and outreach. We also needed new policies because we realized it was harder to fix a culvert and get permitted to do that, to have that predictability that you were going to have a successful project by the time the money came in and everything lined up. We needed policies that made it easier to fix these culverts and to have streamlined, if you will, culvert permitting rules, making sure we still are safe with the stream, but that it can happen much more quickly, knowing that in the long run, a healthy stream simulated designed crossing will adjust and adapt, and streams are used to adapting, they're used to disturbances, but they're not used to permanent disturbances. So by having these policies in place from the federal level to the state and even local levels, we can produce more better crossings. One of the great innovations recently was our ability to find flood insurance rules that allowed us to spend money to fix something that would have been an insurance problem. And several people have mentioned that it's cheaper in the long run to fix these the right way than to deal with the emergency disaster of fixing a road in the disaster, the environmental catastrophe downstream, as well as the potential catastrophe for people in the road network and commerce. So education and outreach is a crucial component. As we saw, a lot of people identified lack of knowledge and understanding. We need to educate our regulators so they know when they're looking at a problem. Our planners, our state highway engineers particularly need education of what a stream should look like, what a stream crossing should allow. And I think this needs to start in schools as well. We haven't quite figured this out, how to get people like Bob Gubernick and Dan Senderelli and others teaching smart road crossings in engineering schools, and also to coupling that with climate science so we understand how bad this problem can be in the future as these bigger and more severe storms and droughts in between affect our rivers and streams. And we need to network. The more we connect with one another, the better we are at sharing information, the good things and the bad things especially, and getting better at this work. And we do that in many ways through events with, there's our senator from the state of Maine in the upper left corner, but also events with kids, make sure that when we do have a restoration event, if it's possible to bring people there and make a big deal about it and get it in the news and excite and engage scientists and teachers. And we do a lot of this through World Fish Migration Foundation events like World Fish Migration Day, the Sea to Source book. This is a way to get excitement out there, to inspire people and then connect them with the information. And then we need to implement projects. We've seen a lot of examples of these before and after pictures, but we really need to get the projects done, one, so we can share with the people who are maintaining these roads locally what good solutions look like, so everyone along the way can understand it. And then we need to make sure we celebrate it so people have that pride that they need to carry on and spread the word. And maybe the next culvert crossing they come to, they'll think of a fish-friendly solution rather than what they would have done otherwise. So in the end, for big system changes, we need the data, of course. We need to be able to process the data and point people to the most important places for habitat and flood risk. We need this network among partners to grow. If we could all be like the Swedes and have agencies work together with NGOs, that would be great. I know it's not perfect there. It's not perfect here either. But by continuing to build relationships and talk with one another, we can get better at this. And then we need these enabling factors, the policy, the funding mechanisms. We need to inspire and educate people. And we need to measure results and report back when they're successful, but also when they're not successful. So that's a real quick whirlwind tour of what we're doing in Maine to create whole systems that look at all road crossings, from the local private landowners to the state to the federal roads. And thank you.
Thank you, Joshua. That was a wonderful presentation. Look, there is a quick question for you about materials. Are there any materials on your website that people can access and share with engineering students?
I wish we had materials specifically designed for engineering students. Maybe the Forest Service does, because they have a lot of engineers. We have some designs that we've used and we'll be happy to share those. And there's also a whole education component through Stream Smart, which you can look online for Stream Smart in Maine. It's been shared with other states, and we hope to have something similar that we can adapt for different countries in Europe in different languages.
Okay. I see there's another question, but maybe Ruben, you can keep that one for the discussion session. And yes, thank you again. And let's move to the next speaker.
Thank you.
Our next, yes, Herman?
It's Mark, I think. Mark from
Yes, it's Mark, and we're going to see a video. It's not a speaker, so
Mark.
that's my fault.
Yeah, Mark, are you around? Just to say a couple of words.
Yes, just a short introduction. We are about to see a video prepared by Mark Weinhold, who works as an hydrologist and hydraulic engineer for the U.S. Forest Service, and he has been working in the field of aquatic organism passage for over 25 years now, right? And this video will show us what a culvert looks like from the inside, I suppose.
Yeah.
I will leave it up to you to explain us, yes.
We're actually supposed to do an interview in the field like Luke did.
Yes.
The only problem was that we didn't have service where we were working, And then it took so long for me to get started that it was cold and snowy, so no one wanted to help me. So I made a video, and I think the take-home message here will be, don't let an engineer go unsupervised and make a video. So Herman, if you could play it from your direction, that would be great. I don't think we've paid our internet bill in the United States, so we're having a little trouble here.
No, it's fine. Thanks, Mark. It's a really nice video. So let's see it. Let me see. Do you see my screen? Yeah.
Hello, my name is Mark Weinhold, and I'm a hydrologist and an engineer with the United States Forest Service. And for the topic of road dams, we have, I will say, some special insight, because as an agency, we are land managers. Millions of hectares of land that we manage, along with enough miles of road to go around the earth 15 times. So we are very familiar with the conflict that roads have with streams. And so we have been working for decades to arrive at a method that we call stream simulation, that in a nutshell is rebuilding the stream and then putting a lid over it. And that lid could be a bridge, that lid could be a box culvert, it could be any sort of an open bottom structure with a concrete footing, for example. It can even be an enclosed pipe that is countersunk. The important feature of all of those is that it allows for a natural stream bed to go through the structure. So I'm going to give you a little bit of a virtual tour of one site near me that shows a lot of the features that we think are important for stream simulation, and how to build that bed and how to get the right material in there and provide the right width so this stream can essentially act like a stream. It can accommodate floods, the bed can adjust as it needs to, and our transportation system is not at risk from big floods anymore. So I guess I'm going to be interviewing myself and asking very leading questions, and I'll consider them and give an answer and see if I can show you something that is of interest and fits with the theme of everything else you've been talking about today. So stand by, I'll move to another location.
So some of you are probably thinking, wow, that looks really good, just like a stream. How did you know how wide to build it, or how big those steps through there should be, or how big the bed material should be? Well, that's that whole reference reach idea. We don't claim to be the smartest people around, but we're pretty good at copying stuff, and that's exactly what we did. The key features of channels in this environment with big bed material and steep gradients is the step pool sequence, and that's just how energy is dissipated. Each one of these steps has its own height, and it has a pool depth associated with that height, and a pool dimension as well, all things that we can measure and recreate inside our structure. I finally thought of a benefit to being out here in the snow. That is how well it shows the actual width variability in these channels. And a channel at a certain gradient is not one single width. It varies whether you're in a pool or a riffle or over the top of a step. Notice the diversity of the bed material that makes up this channel. Everything from large boulders, transitioning to cobble, large gravel, and eventually in the margins you'll see a fair amount of sand and fine gravel, which is likely the bulk of the material that moves down this channel in any given year. But the mixture of all these materials is important to bring back into our design structure to make sure that the complexity is formed and the bed is actually sealed. In stream simulation, we pay a lot of attention to width, particularly the width of the structure, but also reestablishing the width at the inlet and outlet of the existing pipe that has likely been modified from an undersized pipe being in there for decades. There's no snow inside of here, but you can see the variability that goes with this channel. Narrow at the steps, wide at the pools, narrowing up again at the riffles. A lot of hydraulic diversity in here, which adds up to a lot of habitat diversity as well. As a general rule, we like having bank lines in the structure. This provides that diversity along the edges, keeps the stream from adopting one side of the channel, and protects your footing over the long run. All right, now you have to quit imagining that you're a fish and imagine you're a small mammal or an amphibian. Wouldn't you much rather traverse along there and go over the top of this road and risk it and run over? I think I would. Well, I can't think of any more questions that you might want to ask me, so I may just have to wrap it up and be content with looking forward to the day where we get to see each other in person again. All right, have a great day.
Well, that was simply great. I think that we're going to give the questions for the discussion session as we need to move forward. Is that right, Herman?
There's somebody working on an excavator.
Sorry?
There's an excavator in the webinar. It's me.
Unmute. Yes, so I was muted. Fantastic.
Yeah. Well,
what I was saying, if you were not listening, is that if there are questions, we will address them by the end of the webinar when we have the discussion session, and we can now move to our next presentation. Right, our next speaker comes from Finland, and her name is Jenny Jyrkenkallio-Mikkola. Jenny will walk us into the restoration of river connectivity under the Pearl Biodiversity Program. Jenny is a leading freshwater officer at WWF Finland in the program of marine and freshwater environments. She has a PhD in geography, and in her thesis, she studied stream communities and their biogeography. Current freshwater work at WWF Finland is focused on the concrete solutions. So Jenny, the floor is yours.
Thank you so much. Can you hear me well?
Yes, we can hear you very well.
And now for the exciting part of sharing my presentation. Let's see how this turns out. Can you see the full presentation now?
Yes. No, you have to. No, we cannot see it in full. We can see your presentation, but we see also all the slides. So you will have to put it in presentation mode.
Let's try again. How about now?
Let's see. Perfect.
Okay, great. Thank you for the organizers for inviting me to talk a bit about culvert issues in Finland. I will address the history of culvert issues, as well as the pioneer work related to that, current projects, and also the goals and things like that in my presentation. Now changing the slide. Setting the scene in Finland. We are a lot smaller country than the US, but we have the similar problems related to the culverts as everywhere else. We have plenty of lakes, as well as Sweden do, and a very extensive stream network around the lakes and around the rivers. We have approximately 130,000 kilometers of brooks and rills. At the same time, we are the most forested country in Europe. There are a lot of forests around, but it's very important to say that the strictly protected forests cover only 6% of the total forest area. And so forestry can be then practiced pretty much everywhere else. And why this is relevant in terms of the topic today, I will address a bit later on. Now on this map, you can see the ecological status of Finnish surface waters. We have plenty of waters that are in high and good ecological status, but mind the scale on the map where we cannot see the headwaters at all. And like in many other countries as well, our rivers are threatened. The red list of habitat types nationwide level says that 44% of our streams and rivers are listed as threatened. Then I would like to point out that in addition to the official water bodies, the really small ones above these official water bodies that had the catchment area lower than 10 square kilometers are really not recognized as real water bodies, and their protection is not as efficient as in the official water bodies. And as we've learned today, the headwaters are really important places for freshwater biodiversity. In Finland, they are very important spawning grounds of migratory fish as well, but also harbor unique assemblages of other aquatic organisms. So that would need to always keep in mind when we think of the protection of these areas. In Finland, we have really grim history of draining our mires and wetland for the purposes of forestry and agriculture. And on this map, you can see that the red lines represent public roads, larger ones and minor ones, but all the black lines then represent forest roads and private roads, and they crisscross around water bodies and streams and in very many locations. And the scale on this map is only 2 kilometers, as you can see on the lower left corner of the map. But this is pretty much the situation all around in Finland. So this is just to set the scenario of how many culverts we actually have even in Finland, and especially on the headstream areas, as we've learned today. Huge number of culverts. The pioneer work on culvert issues in Finland started mainly by Mr. Anssi Eloranta. And they, with Antti Eloranta together, made a survey in central Finland region where they actually mapped 2,000 crossing structures, more thoroughly, a bit more than 1,400. 73% of the crossing structures turned out to be culverts. And after doing this survey, they made an estimation to the whole country level that there are approximately 120,000 crossing structures in Finland, where from 90,000 to 95,000 are actually culverts. And more importantly, that at least a third of them are total migration obstacles. This is a number which then tells, at least to me, that a lot of actors are needed to actually improve this issue in Finland as well. And this is the central Finland region is now more thoroughly mapped, but obviously we have all the other regions which are not as thoroughly mapped as the central Finland. Another very important work has been done by Finnish Forest Administration, which is a state-owned enterprise that takes care of state-owned forests and conservation areas. They had a couple of project Esteet Pois projects in Oulujoki River Basin, where they mapped more thoroughly the migration obstacles. And in the first one, they mapped 628 crossing structures, and 52% of them proved out to be total migration obstacles. So that's a big number. They did restorations on the sites and opened free migration routes for fish. After that, there was a second Esteet Pois project which continued the work, removed also obstacles, but then also prepared a guide how to repair the culverts and published that. The very important issue would be to get these instructions into Forest Road Manual, which is published by Metsäteho, and this is used by all forest road constructors. This is still in progress, but it is a very good way to go forward to actually spread the knowledge how to decrease the problems caused by the culverts. A little bit about the money in Esteet Pois projects. On average, the cost of one site cost a bit more than 1,000 euros. 35 tons of stone material were used for the restoration, and it took about 6 excavator working hours. Finnish Forest Administration has removed altogether 207 obstacles and opened 514 kilometers for free migration between 2016 and 21. We as an organization have not just sit silent on this issue. Actually, our work related to the migration obstacles started with a project that focused on culverts. And now 3 years later, we are removing larger dams or even active hydropower dams, and the general and political views have changed towards free flowing rivers. So it's really exciting to see the progress in Finland, and we have a good thing going on here. We did a lot of advocacy work related to the Private Roads Act as well, related to the legislation. The Private Roads Act was a really good win to get an addition into the act that if you get subsidies for road maintenance, then you need to reconsider fish passages and fish migration as well. So that was a really big win. We arranged roundtable for forestry companies. Forestry companies very rarely apply for subsidies for road fixing. They do that by themselves. So that was a good roundtable to spread the knowledge to these companies, which are really important in Finland. Within the past 5 years, we have, together with other actors, removed 20 culverts that were migration obstacles, namely in 2 projects, Patokato and K-fish paths. And I will show a few examples in next slides. In Juottimenoja Pernio, we work together with Wallonia, organization that works in a southwest part of Finland, and removed the total migration obstacle to a quite pretty one. I really think that the right-hand side of the picture is a pretty looking stream. And we even got some results out of that. The red arrow represents the time of the restoration, and after that the trout fry densities then became much higher level. So that was a good cooperation site. Then we had Ruominoja in Ruovesi, where we work together with Virho, which is an association that focuses on stream restorations in Finland, and changed a total migration obstacle to a much more functional one, where we can actually see these kind of baffles inside the culvert that decrease the flow of the water and help the migratory fish to go forward. And then last example, Ylösjoki Hollola, where we work together with a large retailer, K-Fish Ways. Made in Belongs to All project, where we worked with stream restorations and also with culverts. So this is just to say, in many cases, these sites are worked together in cooperation with other actors and landowners and water protection association and so forth. And obviously, at the same time, when we remove the culvert or restore the river as well, and add spawning grounds at the same time. It's really, really cost beneficial to do that. So we have proceeded in a way in many sites. Really important program in Finland is a Helmi program that is led by the Ministry of the Environment that aims to strengthen the Finland's biodiversity and safeguard the vital ecosystem services. And the goals related to culverts are to restore 200 kilometers of small water bodies on conservation areas. And the measures include removal of culverts as well. And then to restore migration possibilities to 700 small water bodies on private land outside the conservation areas. And there obviously remove these culverts as well. And then a high number to remove 970 migration obstacles from state-owned area, which is then responsibility of the Finnish Forest Administration. So we have a really good progress going on in Finland, I would say. Threats, opportunities, and to-dos. As we've learned today, climate change poses a challenge for culvert issues as well. They might harm them, and when they need to be then replaced, it would be really, really important and crucial to actually replace them in a way that they don't cause any more harmful effects. In the near future, we have increasing needs to renew our forest roads and private roads, and this is a very crucial step forward and make a change there. It's important to get the instructions to the road building companies into the Metsäteho forest guidance. That's a very large step to take forward. And then getting the obligations to actually notify when these projects of culverts are done into the Water Act, where it's not included in the Water Act now. So that's something to do. And then
one more minute, Jenny.
Great. This is my last slide.
Perfect.
So I've listed some ideas if you would like to work on culvert issues and have done that do not do that now. The first issue would be to find out who owns and maintains these structures for the roads, for public roads, forest road, and also railroads, not to actually forget also the railroads. And then what kind of legal obligations are related to these structures? Removal and retrofit culvert is really relatively cheap, but then you could get cost beneficial, or it would be cost beneficial to actually do that with the road maintenance if that is to be done. To prioritize is obviously always good, but every single removal or retrofit helps the issue, keeping in mind that headwater areas are really, really important for the freshwater biodiversity. And obviously, if there are many obstacles blocking the same streets, start from the lowermost point downstream. And once more, lots of actors and cooperation is needed to get this thing fixed nationwide, European-wise and global-wise. So I'm sorry if I passed my time here, but with that, I would like to thank you for your attention.
No worries at all, Jenny. That was really worth it, and it was a very interesting presentation, and also impressive work you're doing in Finland. I found very interesting the initiative on this forest road manual that you're working on. However, remains quite disturbing to see the huge number of culverts covering our European geography, but we are working on it, right?
Yes.
Well, thank you again.
Thank you.
In our next section, Mark Redeker and Stefan Whale will talk with us about the work that they are doing on a guidance for practitioners on culvert replacement. And my colleague Herman will help us find more and also find more about Mark and Stefan. Please go ahead, Herman.
Hey, yes, thanks. Amazing presentations, by the way. It's really nice to see that things are moving forward in Europe and that we have lots of challenges. And I think, speaking of lots of challenges, Mark and Stefan, you have come up with some tools that might help in these challenges. And Mark, you work at CDM Smith in Germany. Can you tell a little bit more about what you're doing related to guidances for culverts?
Yeah, sure. So actually, I'm involved in the development of 2 guidelines at the moment. Here in Germany, I head the German Technical Committee on Fishways, and as part of one of the things that we're doing there, we're working on the revision of our national fish pass standard that basically we published in 2014, and one of the sections in that guideline is on crossing structures such as culverts, tidal structures, and flood retention basins. But probably the second one is more appropriate to this webinar's topics. And because it's available in English as well, is my colleagues and I have just recently completed a guidance for the Office of Public Works in Ireland. Yep. And the Office of Public Works commissioned us to develop a design guidance for fish passage in small barriers. So, and they wanted to test that at 10 priority barriers in the Inni River catchment. That's a sort of a pilot river basin in Central Ireland. And we developed this guidance together with a project steering committee of other public bodies in Ireland. And it really includes 3 key elements, which I think, and it's sort of popped up in this webinar as well. One of the things is a decision tree to actually identify the best mitigation approach that could be sort of removal, reconstruction, or improvement. Second one is a matrix that allows the improvement measures to be chosen specific to the barrier issue. And the third one is very much in the interest of the OPW for their operation and maintenance staff, is to have really generic designs that they can use in the field to jump in and do the works that are necessary. And the way we've structured this guidance is really for practitioners, and it can now be used countrywide, not only in that pilot basin, but for a variety of target species as well.
And will it be applicable for the rest of Europe?
Yeah, it can be adapted. We've chosen it specifically for the Irish fish species, but that could be adapted quite easily, and that, as I say, could be done quite quickly actually.
It's almost available for the European audience.
It is already available on the website of OPW. It's undergoing sort of a more corporate identity lookout at the moment, but you can download it. I put together some guidances that I'm aware of. You can distribute it after the webinar, and there's a hyperlink in those sheets for the download of the guidance.
What a nice image on the background. Did you make it yourself?
No, that's actually one of the issues we're working on as CDM Smith in Germany. Is on the Wupper River. It's a salmon restoration tributary to the Rhine, and this is one of the problematic culverts. You might see the drop and the turbulence at the bottom, high velocities in the barrel, and we're just working with the River Association to remediate the issues there.
Thanks, Mark. Let's go to Stefan. Stefan, you work for an NGO in France, and you're working on a guidance, I think, for practitioners too. Can you explain a little bit about that?
Yes, sure, with pleasure, Herman. I want to thank you very much, you and Yurena and Nicole, for this excellent webinar. It's very encouraging seeing that so many people are interested and concerned by this subject. Yes, our NGO has institutional members such as water agencies, department councils, and Federation for Fishing and River Protecting. We are based in France, as you said, in Normandy, where we have something like 20,000 river kilometers. We have either chalk stream or granitic substrate. Around here, agriculture is the main activity, with cattle and cereals. We have big stakes for migratory fish, like salmon, sea trout, eels, shells or lamprey, but also for resident fish like brown and trouts, we've seen already before. And to answer you, our mission is to help with technical tools the project holders or stakeholders for river and wetlands restoration. We try to make these projects dimension to river basin catchments in order to reach good water estates considering European Water Framework Directive. I think Jenny told about this just before. And you and Nicole may maybe provide a link to some of the technical guides we already proposed concerning culverts, for example. Our main targets, our assistance missions, is natural managing for riparian vegetation, protecting small streams from cattle, because here in Normandy, where you might have heard of local cheese like Camembert, in some places we have more cows than inhabitants. We also have in our project removing drainage from wetlands and trying obviously to erase morphological damages such as dam and also culverts. Restoring ecological continuity is one of our big deal and challenge here around, as in many other places we've seen before. So in our very agricultural region, where about 75% of the hydraulic network is less than 3 meters wide, culverts are a very serious cause of breaking ecological continuity. We have identified an average of 1.5 culverts per stream kilometers in our place, and up to 2.3 culverts per kilometers in some river catchment. That's big fragmentation. We also identified with genetical surveys, we found some difference between brown trout population, whether they are over or up on the culverts. So we feel that it's no good points when you have to adapt your evolution to climate change, for example.
Thank you, Stefan. I think we have to move on, but I want to thank you both for being here and sharing with us the links to the documents and the new guidances. Yeah, thank you very much, and hope to see you soon again.
See you soon. Bye-bye.
Bye-bye.
Thanks, Mark. Thanks, Stefan. Well, we have reached almost the final stage of this webinar on road dams in Europe. But before we get there, let's hear from Kim Arestrup. I hope I pronounced well your name, Kim, from the Danish Technical University, on how this topic can become a business as usual in Europe. I would like to ask you, Kim, before you start your presentation, to say a few words about you so we get to know you a bit better.
Hello, Yurena, and hello, everybody. And thanks for inviting me. I can see I counted there was up to about 620 people participating, and we're down to 500. So to the 500 who left, well done that you stayed the full. To the 100 who left, you're not missing point, because I think most of the points what you've seen today, I'm not gonna change it a lot. There's a lot to be learned, but there are also some things that I would like to address, because I've been working on this. I started as a master student working on fish passage in terms of that, and I have moved to other parts now, but I still maintain contact with the area. So I just wanted to flag a few things, and I'll see if I can share my screen. That one. Can you see my screen?
Perfect. Yes.
Let's see if it works too. So that means I probably have to go here. Yeah, there we go. So when Herman approached me back in time and said, we're doing a culvert seminar and we have massive challenges in terms of that, I'm like, okay. And he convinced me to come give a talk, and I told him that, and I guess that's why he asked me, because he knows I'm usually a bit provocative, saying I'm not gonna run through all kinds of stuff, but I'm gonna tell you my perception of where we are today and why we are there today. So that's what I'll be going through today, and I'll be going through these 4 scenarios about WTF. I don't know if people know, I think most English people knows what that means, and then about a concept called shifting baselines. What I think you should take with you home if you want to make this simple, and how and what to do in order to make that sort of business as usual. So this is a CD, and I'm putting that in because in my days, that was in 1995, 1994, when I started working with this. I got a CD from a state in US where there was a full CD, nicely printed with videos and guidance to how to adapt culverts to pass aquatic organisms, sort of in the broader sense. And I was a bit surprised and say, well, US, is that one of the underdeveloped countries or something? Because I had been involved in river restoration and culvert restoration and remediation when I was a teenager. Like back when I was playing computer on Commodore 64. And it's like, so but I stand corrected. Certainly it's a massive problem. It's still a massive problem. And where are we today? Well, we know something about the absolute smallest in the world. This is the Higgs boson, for the ones who doesn't know, particle that they work with CERN in Switzerland. We just sent up the Webb telescope that's going to take us to the furthest reaches of the universe on a massive large scale. But our own backyard, we still haven't managed to sort out. I think Carlos showed it very eloquently how big a problem, how many there are here. And there have been a lot of good projects, and I really commend, Sophia said it, Jenny said it, Joshua said it, everybody has, there's a lot of good things going on, but the problem is of such a massive scale. So how come that something that was essentially the solutions were ready 2 generations ago, why is it that we're still here battling this massive problem? So, and I think I'll put to you that that's something to do with shifting baselines, or what you call environmental generational amnesia, that's the EGA. So essentially the bottom line is that each generation starts out and experiences nature, including rivers and stuff, as kids. You maintain that view sort of as a baseline of what nature is. When nature then deteriorates in your timeline, you forget that new generations, they grow up, experience a deteriorated nature, and that cycle repeats. And once all our old farts, Joshua, Herman, Carlos, me and stuff, are at some point retired, all the stuff we're talking about here, how do we maintain that? There is a generational gap. You have to transfer that into the new generations, the younger people here in the audience who has to carry this torch on to make it do it. Just to give you a concept of here, I don't propose to be as old as this guy here, but he has a Netflix series, David Attenborough, by the way, for the ones who doesn't know him, called A Life Lived on Earth or something like that. And I encourage you to see it, because in that you can see also that part, that deterioration in nature that he has experienced in his lifetime. So keep that in the back of your mind when you're working with this, when you're trying to make this bigger, when you're trying to make this very, very good. Educate the kids, educate the younger generations, make sure that this is a legacy that stays on. So, and where are we in Denmark? Well, I have to say that in that sense, we are not better than anybody else. It's stupidity within stupidity, as you see on the upper left. Not only do you have a stream that's put into concrete and kind of, but you also make a drop inside it, making absolutely sure that there are no animals or no fish or anything aquatic that can pass here. The other thing that we are challenged about is that, let me just get rid of this one, is that things change, politicians change, political change, and I can tell you that just a few years ago, we had a minister of fisheries in Denmark, and there was some debate at some point, and his argument was, well, there's a lot of nature in cornfields, so that's why I put the cornfield in. So if that's the perception what nature is, we're at odds. The people who've been out there experiencing know that's of course not the case, but there's actually people doing that. He got sacked, by the way, because he did some, I can't remember, he did some phony things about the fisheries, so he got kicked out. Now he works at a prestigious environmental institute in US, making environmental analysis, just for your reference. So, so what is to take away here from what we've done in Denmark? And I think that fits into everything else we see here in this context. That is, there's some simple ground rules you should follow, some simple guidelines. You should aim higher. You need to avoid these passive problems from the aquatic organisms. And I'm talking about in the broader sense from the beginning. I know fish is very important, but there are more things out there. There are lots of things that we don't know anything about, and we can investigate ourselves to death, and we will never grasp the full concept of what the connections are out there. So avoid the problems from the beginning. And number one there is, do not change the original gradient of the river, period. And number two, and I can think you can get that from all the talks here today. Use pipes that are big enough to allow both natural bottom structure and take all the water. Because that means you allow access for the aquatic organisms that were there anyway. And then, yes, there are loads of already existing culverts. And I encourage you to go to point 1 and 2 and start again. And in number 4 is that when you end up here down again, I certainly encourage you to do it again. You need to try, you need to aim higher. That's why I put it in twice. It's not a mistake, it's on purpose. But if you still end down here and need to reconfigure the stream, then there are ways to do that. You have to do it and be aware of it on both sides, but you certainly have to be aware of how to allow passage. And in that sense, I will show you, let's see if I can move on here. Why can't I like this? No. Can everybody hear me, or did I lose you?
Yes, yes, we can hear you very well. Are you having problems moving?
There we go. So let's see. Yeah. So this is some of the current things we're doing in Denmark, and you'll find the familiar design. So essentially building this bridge-like structure, or this culvert-like, half culvert-like structure, I put in the Volvo V70 for scale. This is just for a normal small stream. Just mind you, we don't have, well, to be all honest, we probably don't have rivers in Denmark, but we certainly only have a lot of small streams. It's a lowland country. We're talking about a stream there that's maybe 3 or 4 meters wide. So that's just to say, make them big enough and make them so you don't interfere with the bottom substrate, because it's sediments, it's all kind of animals. And if you don't change the gradient, you should be safe in terms of this. Right? There's a smaller one here, and you can see how it looks when it's put in, that it will be able to take all the water. This one is actually slightly smaller than I would prefer, but at least that's it's a way to go. I would prefer you go this way. Here you have made it significantly larger, so you can take all these flood events, and you use the opportunity to put in a bike path so people can come out and see the nature. You can also just leave it for the original sediment, depending on what you want. This is in a rural area. And then finally, just one more thing in terms of making it big enough. This is a YouTube video you can watch later. That's actually from a US guy who's out, and he removes beaver barriers that they make on the culverts. And it's pretty funny of him seeing that he takes down these beaver dams, and I just put this picture in here where he films in through the pipe, removes the beaver dams, and 1 hour later he comes back, and that's how it looks. So I'm just telling you, especially also you UK guys, because I know beaver is really hot over there. Just be aware that you have to make them big enough for the beavers, because otherwise if you make it too small, you're going to have to come back again and again and again to remove them if you want to maintain your roads. So just as I said here in Denmark, what we do in Denmark, when we end up and cannot do anything about it, we do that. We essentially put in rough substrate and mimic what happens in the stream itself. So we lift, so there's actually access. You can see it before and after. You can see now there's sediment inside the pipe. You can see the water level is lifted. It's also over a gradient so that it's passable for aquatic organisms. We do the same on the upper end if it's necessary. And one more thing I would like to engage is that we do really a lot here on a smaller scale where we engage locals. That's typically anglers or people interested in nature. You come out, you make this project. Essentially, there is a lot of will by engaged peoples out there who will help you to do this. And essentially all you have to pay for is the gravel. They'll come in their own free time and help you do it. This is a part where you can see here, you can see the pipe in the background, and people are now aligning this drop here over a longer stretch so that it's fully passable. And you can see how happy they look. And this essentially is how it looks after this is made. And you can see it's also habitat that's adapted to this lowland stream. And this is actually a spawning place for sea trout and salmon at the moment. So I will encourage you to engage people, both in terms of also make sure that you have this legacy, that there will be people of different age who knows what a good solution is. If you engage the locals, they also will be able to affect, or at least push politicians and decision makers to make sure that this is something that is important. and ensure that also they will spread that message to other people. So use locals and engage people to spread the message and make this sort of a bigger movements, also sort of like Herman is doing with this organization, Fish Migration. So how do we become this bigger business as usual? I said here, well, again, bottom line, aim higher, make it correct and long lasting the first time, which typically means you have to make them bigger. I think we cannot get around that we need stronger legislation, and I can hear across the board, I'm only familiar with a few countries' legislation, and I know that lots of countries has like the forestry in Finland and stuff. If you put a legislation in saying that you cannot make a new road construction without a culvert that has been approved by some form of expert, then I think you will solve a lot of the problems, at least over time, because it is of a massive scale what we're talking about. As I said, engage locals. Then one thing I haven't touched much upon, but it's been shown in some of the other presentations, measure the effect. We've seen it on trout and salmon, and publish it. That will also ensure if you publish it, it is actually somewhat time resistant. That means people can revert to it. Don't let it sit on your disk, get it out there. And it's not enough that you have a lecture somewhere or you talk to the local municipalities. You need to get it out in a format where people can approach it. That should ensure the legacy if you then do what I've suggested you here. And in that sense, I think then we're on a path to finally getting the upper hand of this culvert issue that should have been, in my opinion, fixed long ago. So go out there and make the world a better place, culvert by culvert. And thank you for listening.
Thank you very much, Kim. That was a powerful reflection and really useful guidelines that highlight the power of strong planning and aiming as high as possible. And I like your final, I don't know how to call it, this final phrase, make the world a better place, culvert by culvert. Thank you. We are almost there, but before we move to the discussion and also the final part of our event, I would like to remind you that the World Fish Migration Day is approaching, and World Fish Migration Foundation is organizing a campaign. But Herman, would you like to say something more about this upcoming day?
Yeah, and thank you, Yurena, and also thank you, Kim, for amazing tips. Yeah, you were talking about engaging and awareness, and I think the World Fish Migration Day is a great way to raise awareness for your topics, for your challenges, for your celebrations, and showing people what can be done and make them engaged. And this will be the 5th anniversary of the World Fish Migration Day in May 2021 this year. And our theme for this year is break free. So we're gonna break free. We're gonna help the fish to break free. We're gonna break free ourselves and go out again. And hopefully the corona is over by then. And this is an image of the last World Fish Migration Day. But just to show you how amazing this and how big it is. It starts in New Zealand and it travels around the world. It ends on Hawaii, and in the last years, we had like 1,500 events in total and 3,000 organizations involved. And this year, we're going to have a World Fish Migration Day headquarter in Portugal. And we're going to combine it with a seminar about dam removal and how to scale up dam removal in Europe. We are currently planning that seminar, but we are already getting other organizations also hosting webinars and seminars, but also events outside, eel counts, all kinds of events are welcome. We would like to invite you to sign our petition to save free-flowing rivers. We're going to bring that petition to the Biodiversity COP in China. It's on the website, worldfishmigrationday.com petition, and it can be signed by organizations. And at this point, we have 380 or 370 organizations from over 80 countries, I think, that have signed the petition already. And we're going to do something special for kids this year. We have cooperated with the Wildlife Forever from the US, an NGO that is specialized in education campaigns. And we had a fish art campaign in the last years, but this time we're going to do it different. We're going to do a fish flags campaign. We're going to ask children to create beautiful fish flags and to hang them outside on World Fish Migration Day. And this is actually the start of the campaign. So I'm going to show you the promo movie and then we move to the discussion again. So here's the promo movie, and I hope that you have kids, or you know kids, or you know schools that want to be involved and create these beautiful flags. Here we go. Thank you.
Thanks, Herman. I've seen a lot of traffic in the chat box, and I think that the chat box really ran mad. There was something crazy going on there, because I think that I've never seen so much reactions. I want now to invite Dan Senderelli, Mark Weinhold, and my colleague Ruben to tell me what's going on in the chat box. Are there any reflections there, or some questions that just caught your attention and that you think that we should mention them here, or something to discuss interesting?
Yes, thanks, Yurena. Thanks for the moderation. It was absolutely delightful. I've rarely been entertained that well, I might say.
Thank you.
We identified a few very interesting questions. Indeed, some of them have been answered anecdotally, or at least shortly in the chat, but I think there are a few that are worth exploring in more detail. And Mark and Dan have helped me compile a list. Thank you very much to the two of them. It was a great effort, like with so many of you contributing to the chat and to the questions. Thank you very much. It was quite overwhelming and amazing to see with so many hundreds of you joining in. And let's see how much time we got. We have one question from the Mentimeter poll that we were very interested in discussing or sharing with you. We have like 2 or 3 more that are more technical, and then something on how to move forward from here, like a kind of a lessons learned thing. And maybe Mark or Dan, would you be interested in sharing a question from the Mentimeter poll? Would that be all right with you?
Only if it's not too hard.
Well, we'll see about that.
Yes. You know, there was a question on that about cost, and I think either you know, there's several people that can answer that. And I think Bob addressed this in his presentation about the cost of stream simulation culverts. And up front, they do cost more because they're a little bit larger structure. You have to excavate a little bit more, but your savings for the long term come really apparent because you don't need to do chronic maintenance of removing sediment or debris from the culvert inlet. And the culverts will also last longer. And so that cost really becomes, actually, it's a cost saving when you look at it over 50, 60, 70 years versus just looking at that initial construction cost. So that's something to consider. And then there's some very big benefits from an ecosystem services, because that road does not fail. You maintain transportation for people who are accessing their land, their property, and so forth. And so emergency vehicles can get where they need to get because the road is still in place. So there's a lot of other benefits that don't necessarily get thought about when we're replacing these structures. But, you know, ultimately, you know, when you think long term, the cost benefits are, you know, quite apparent. And that's probably the take home message with that, is that we need to not look at just the initial upfront costs, but think about those cost savings for 50, 60, 70 years.
Thank you very much, Dan. We do have another question I would like to address to Mark, if that's okay. And that's whether a retrofit of an existing culvert or like a weir or baffle or whatever is appropriate in what sense? Like in what sense is a retrofit, or in what occasion, I guess, is a retrofit of a culvert appropriate? And what could be a trade-off compared to a full replacement?
Yeah, I think what you'll find, you've already found this, I'm sure, in Europe, and we have in the United States, that when you have thousands and thousands of culvert barriers, the temptation is to do something fast and inexpensive, which is often a retrofit. So the idea of coming back and putting in some baffles or weirs or something like that to change the hydraulic structure inside a pipe is a reasonable thing to think about, and it can actually have some short-term benefits. But what I would throw out there, there's some limitations on that. And one is that when you put a new structure inside of a pipe, one, you lose cross-sectional area, and two, you change the roughness inside of the pipe. And so for the engineers who are listening, that means a lot of lost capacity. Even the rubber ones that fold over still change the roughness and take up some cross-sectional area. So when we're looking at the long-term viability of these structures, particularly through the lens of climate change, losing capacity is a big deal, because I would suggest that there are very few existing culverts out there that are oversized and have excess capacity to work with. So we're creating a hydraulic problem by doing that, but we're solving an issue with passage for probably one species when we do it. So there is some benefit, but we're still excluding a large part of the population out there, particularly juveniles who can't get by those things typically. So it does provide some benefit in the short term. To me, it just moves it down your priority list. It doesn't take it off of it. So you're still going to have to deal with it. You just bought yourself a little time.
Thanks a lot. Yurena, do we have time for more questions? I guess
yes,
so.
Let's do maybe two more. I also realized it in the chat box, so most of the questions were answered, which is great. But let's just drop a couple more questions and then we can conclude.
Okay, so there's something that I think is very important to bring up. Skipping basically to the end of my question bullet point list here, and this is what we learned from it, or how we move forward from here. A lot of people in the chat and also during their talks have mentioned that engaging stakeholders in the public and closing ranks among NGOs and offices and universities even might be one of the key areas. And this is something that I have frequently seen here, and also was one of the results in the Mentimeter poll, I believe, or at least that's something that we could indirectly infer from one of the Mentimeter polls. And I think there is something that Sophia, was it? From Sweden, was it Sophia? I'm sorry if I got that wrong now. Her great showcase project that worked so well across all different offices.
Live Remibar, yes, that's Sophia from
Yes,
Sweden.
I think that was a fantastic example of how we should try to do things, and I was very tempted to write her a message and ask her on a toolkit on how to work most efficiently in a multidisciplinary sector like that. And I think what we should do is learn from each other in that respect, and talk to each other on how we overcame these specific obstacles that we all encounter sooner or later. And if one of you guys are aware of something super specific, super important, or super successful, I happily invite you to share your recipe right now.
Yeah, that's a good thing, because I wanted to ask Joshua, for example, but I didn't know if we were going to have the time, because you mentioned these multi-targeted solutions to solve the problem with the road crossing. And in doing that, we need to address multiple stakeholders. And that's basically the same thing. And I was wondering, well, what's the challenge, or who are the most challenging stakeholders? But I don't think that there is a single answer, right? So I don't know. Maybe you can provide some feedback on that.
Yeah, I think there is not a single answer, and yet education and awareness is got to be a huge part of it. So we need lessons that can be accessible and exciting and fun, like this webinar, for a planner, a highway engineer, especially to get more students coming out of school, I feel, that understand the problem and what those solutions are. And there could be engineers that are innovating new designs with new materials or old materials, you know, wooden structures that are, we've got wooden bridges that are actually quite inexpensive over waste block concrete for a lot of these smaller streams and forest roads. That's been very successful. So I think there's a need to get the right education formatted so that whether it's for school children or planners or road managers or engineers in school, we have the right level of curriculum and lessons, and that we're sharing all the time. I think creating, like the World Fish Migration Foundation's idea of creating a global Fish Passage Institute, you could imagine having classes just on road crossing designs and materials. That would be incredibly helpful.
Anything else, Ruben? Because if there is one more question, we can.
Yeah, there is one more. If we have time for it, I'll gladly bring it up.
Another one, and we conclude.
Yeah, it's actually a technical question. So going back to the technical aspect of culverts, there seems to be a lot of criteria for the width of a fish passage structure, like a factor of bankful width 1.2 or 1.5, and is there like some? Is that correct? Is there another way to look at things? Is there, you know, is there a guideline? I mean, of course there's a guideline, but what is the guideline, I guess, is the question that we need to ask.
You know, I'll start this and then Mark can weigh in on this as well. I think that, you know, people come up with those criteria is a way of getting a wider structure. And there's nothing wrong with that. But I tend to get technical on this, and I don't want to get too technical here, but you know, bankful width varies along a stream. There's not really one number that we can use. And then ultimately what you're trying to do is that's your starting point, and then sizing the structure to accommodate the form and function of the channel. And so sometimes it'll be 1.2 times bankful, or it may need to be wider or even narrower, depending on the channel type. So what we kind of look at is how the stream needs the width to be able to function properly, versus just using sort of a predetermined criteria that may not be adequate or not appropriate for that crossing. So again, the key there is reading the stream, understanding the stream, and then sizing the structure to get that form and function that you want to work for the long term. And so these criteria are okay to start, but again, I would take that another step further and think about form and function for that crossing for the long term. So maybe Mark can add on to that.
Can I just chip in here? Just one short, I mean, you can do all the calculations you want. You can also just say, listen, what is, as I said, does the natural stream look like? And if you want to be safe, then multiply by 5 and put it in, end of story. And then you can save all that money.
Yeah, that's definitely the kind of quick and dirty approach that I kind of expect from Kim and that I really appreciate. So thanks for that 5-step. This is very insightful.
Well, I feel bad, but I think that I don't think we have to wrap up. Thank you so much. I would like to thank you, the speakers, for your excellent contributions and your talks. And I would like to also thank the organizers, and in special, Sophia. Yes, you have your hand raised. As I won't allow that you don't. Sophia, do you want to say something?
Yeah, I didn't. I couldn't unmute myself, but now I can. Yeah, we actually wrote a manual on how to make road water crossings, but it's a bit old now. I think we have to update it a little bit since there's so much more water now with the climate change. But we do have one, and it's in English as well.
Thank you. I think that we were not able to see you, but it's great that you were there. So thanks for that. So thank you for the organizers, and as I was saying, a special thanks to you, Herman, from World Fish Migration Foundation, for inviting me to moderate this huge event. At the beginning, I counted more than 600 participants. That's simply great. It has been a privilege to be here and an honor to be entrusted with such undertaking at the gathering of such a diverse group of people. I would also like to thank a lot the participants for joining us and for staying there until the end. Without your inputs, all those questions and that information that you have shared with us and your presence, this webinar would not have been the same. We have exceeded expectations, I think, right, Herman, to address those challenges and the opportunities of removing dams, road dams in Europe. But we have an intense journey still ahead of us, and more gatherings like these are so important to place higher in all agendas the importance of removing barriers to open the gates to free-flowing rivers and address the huge crisis we are in, this biodiversity and climate crisis. All presentations will be in Dam Removal Europe's YouTube channel. Herman, would you like to say a couple of words before we formally close? I see that Herman is frozen, but I hope that he can say a couple of words before we conclude.
No, he's gone.
Oh no!
Just a second, guys. Let's see if he can step in again, because I would really like him to say something, and he is the witcher of this. There you go. So
sorry, my connection suddenly dropped. This was the best moment, not while we were doing this, but I had a present for you, Yurena. Originally, you were going to be in Rotterdam. I had this World Fish Migration Day T-shirt for you.
Thank you, Herman. That's fantastic.
Get another time, but
yes.
I would like to have an applause for you. Can everybody like open your mics?
Well,
Yay. Thank you.
Thank you, Herman. Thank you, guys.
It was really wonderful, and you did an amazing job.
You too. Thanks to you too.
Yeah, and I want to thank all the speakers too. And we have been preparing this since, I think it was October, September, and when we started to work with US Forest Service and with the Nature Conservancy, and step by step it was growing, and suddenly we had 1,300 registrations, and today we had over 600 people participating from over 67 countries. Amazing. So thank you very much. And we're going to do it again. We're going to have, soon we're going to have dam removal cafes, which will be webinars, bi-monthly webinars, where we have exciting meetings about the progress made in Europe on dam removal, but also in other parts of the world, to see how barriers are removed, like culverts, and are replaced. And so that's something that is coming soon. Thank you very much. And yeah.
Thanks to you. Enjoy what remains of the day. Be good and stay safe.
All right.
Thanks, everyone.
Bye.
Bye.
Have a great evening. Bye-bye.
Bye-bye.